Assalamu alaikum, ladies and gentlemen. Welcome back to another live stream. Alright, let me just share the link real quick. Copy video URL. Share it with server. Please join my server so you can get notified of new streams. Okay, cool. Alright, let me actually try to share in the Zig Discord server too. Maybe, where is it? There you go. Alright, let's go. Okay, so today we have another guy called the Humanati, I think. welcome. So can you please introduce yourself? I see. Alright. I see. And this is a new concept that we're trying, and you are the second person to try out this concept with me. Pretty much. Is the stream, by the way, fine? Can you verify it real quick? Alright, great. Okay, so I think let's start already. Let's see what we got here. We're gonna run Visual Studio Code. So you can watch the stream right now where I'm gonna show everyone how to install Zig, pretty much. So Zig install, Deloitte. Okay, I'm gonna go with Windows in my case. The latest release, well, it's the Zig actually is not even released yet, so you're just gonna get the latest development. Executable, and we can just unpack it. 7-zip extract 2. There you go. It's gonna take a while since there's a lot of small files inside of this Zig package, but basically install this Zig zip file, right? And you basically get a C compiler, maybe also a C++ compiler, and of course a Zig compiler. So all of these are in basically 72.9 MIGs, and that is possible because of some clever stuff that the Zig team did. Like, for example, they don't include binaries for platforms. They actually include the source code and basically compile what they want to, like what they need. Hello, Clink Live. Welcome to the live stream. Hey, thank you for your streams. They're very inspired. Do you have plans to continue your volcano project? Thanks. I'm not sure if I want to continue my volcano projects, but I mean, we'll see how the future goes. We'll see. If there's support for it, I'll surely continue it, pretty much. Yeah. Okay, so if you guys have any other questions, please let me know. You're welcome to ask any questions anytime. And yeah, I think right now I have actually, okay, there you go. So right now we unpacked Zig and we got a Zig executable. This is a portable executable. Now you could just run it and there you go, done. You have lib here, you have even the standard library here and the documentation and such. So that's pretty cool. All right, so let's actually first of all add this Zig to our path, because right now if we actually run a terminal right now and try to run Zig, this wouldn't work. It's not recognized as the name of cmdlet, so we have to add it to the environment so you can run it from anywhere, not just in this directory, because indeed if you run it from this directory it would actually work. There you go. Hold on a second, it's taking some time. All right, let's see. Come on, why it's taking this long? Interesting. Okay, there you go. All right, so what if I run it again? Okay, so somehow first time it took, yeah, I think it's probably doing some compilation or something like that. Yeah. When the first time you run it, so but like the second time it was very fast. Anyways, so let's add Zig to the environment. So in Windows it's actually pretty simple. In fact, even in Linux, though in Linux you don't even need that. You can just, like, you know, download the package from your package manager too simply. So let's actually go to the path and add that directory there. Okay, and there you go. Right now we have Zig in our path, though of course if we run it here it wouldn't work because we have to restart our terminal to refresh the environment. And now if I actually run Zig, there you go. Now I can run Zig from wherever I want. Now of course I also have to restart right now my Visual Studio Code real quick, and I'm gonna run it again. Okay, so let's go. All right, so I'm gonna be using live share with what should I call you? For like a small name to call you. Vrisco? Oh, your old name, right? Okay, great. Let's go. All right, so Vrisco have live share extension installed already. We have set this up before the live stream, and I also have this on. So right now I'm just gonna launch a read-write session. Well, actually before that, let me first of all make a Zig project. And let's see how to do that. Now, the only disclaimer that I'm giving you right now is the fact that I haven't used Zig for a while now, and Zig is still being constantly developed, so you have to constantly catch, you know, play the mouse and cat game with it. So like you have to constantly catch with the new updates and new breaking changes. Which that's what it sucks about Zig right now. But Zig as the language is pretty good. But like, and also the LSP is that one is pretty trash, honestly. I'm not sure if that changed since last time I used Zig, but we'll see how it goes. Anyways, let's actually make a new project. So Zig. Let's see what we got here. Okay, so initialize the Zig package in the current directory. So first of all, let's make a new directory. I don't know. GS to Zig, I guess. And let's go. By the way, the title of this video is actually suggested by Vrisco, pretty much. I can't make such creative names myself. I have just some blend titles, but like he came with the very crazy title. Actually, that's very good. Anyways, so let's say Zig init right now. Isn't it Zig init-exe? No, it's not. All right, Zig init. Okay, cool. So now I'm just gonna run code right here in this directory, and there you go. Let's go. So right now I actually opened my Zig directory. I'm also going to, as you can see, we have no syntax right now, syntax highlighting and such. So we gotta install the LSP. So Zig language, there you go. Install, and there's also this very nice theme, and it's actually called Framer Dark. There you go. If you install this, you're gonna get that theme. There you go. Zig path hasn't been set. Do you want to specify the path or install Zig? Use Zig in path, please. Recommend enabling ZLS for better. Do I have? No, I don't have ZLS in path. Install it. Hopefully it wouldn't suck, because I remember last time that sucked so bad. All right, let's see. Come on. Okay, well, at least we get signature right now. Great. And we have some syntax highlighting. Cool. So far, so good. Okay, so let me actually start the live session right now. Live share, read and write. And I'm gonna invite Vrisco in. And hello, Wo, GG Girin, welcome back to the live stream. Wa alaikum salam. Invitation link copied. Okay, great. All right, so I'm gonna paste the link to Vrisco, and he's gonna join in. Okay. All right, great. So you have joined right now. That's great. All right, so let me share with you my terminal. Read, write. So I think you don't see any syntax highlighting, right? Can you? All right, can you install the Zig extension, the Zig LSB? Language, Zig language. Just type in Zig in the extensions and you're gonna find it there. Can you share your screen? All right, great. Yeah. Yeah, we already have joined, so, but now you have left. Try to join again. Zig path, so install, no, install. Install. Because you don't have Zig in the system, I think. Can you restart your VS Code? Yeah. Just to make sure I've set it up correctly. Open. All right, install, click on install. It would install Zig for you, I think. Hopefully it would work. Nightly, right? Nightly. Okay, let's see if it would work. Otherwise, we'll have to install Zig manually for you, which you should. But for now, if that works, that would be great. Because you're gonna use my own Zig executable anyways in the terminal. Okay, install. Okay, Zigwood is installed there, great. Now let's wait for, okay, can you hover over any of that and see, make sure if it works? Great, okay, so it works for you, lovely. Thank God the LSP doesn't suck that much. All right, so do you have error length extension? Go to extensions, Control-Shift-X, I think. Yeah, there you go. Look for error length. This is one of the most useful extensions I use. It shows you the error in line instead of every time you have to hover over it. So that would be really helpful. Okay, great. So now you can just close that extension tab. Just close the extension tab, right? There you go. Cool. So can you, how do you close that extension? By the way, can you go to view, maybe appearance, possibly? Hold on, go back, view, or that's fine, that's fine. Anyways, never mind. Okay, so you can right now just stop the stream and we can go forward with VS Code right now. Okay, great. Okay, so now we can begin. Great. All right, so let me share with you my terminal too. Okay, remove. Oh, it's already shared, I think. Try to run Zig build on my terminal. Okay, there you go. It works. Great. Let's see. Run. Okay. Zig build run. Yep. All your code base are belong to us. Run Zig build test. Last time I tried Zig test wasn't working on Windows. See if that works now. Interesting. Okay, try commenting this. Try comment this out. List init. List the init. Yeah. Now Zig build test again. I guess maybe it doesn't work anymore. No, it's supposed to tell you that you have forgot to deinitialize the list. You have, yeah. So I think test still doesn't work on Windows. The Zig test. Anyways, never mind. So right now we're just gonna go from scratch. So just remove all of this, pretty much all of it, literally. Okay, cool. So let's start by the main function, fn main. Fn main. All right, great. And after the parentheses of the main function, you do the return type, which is, let's say void, right? And now inside the main function, we're gonna need the standard library though to do anything interesting. So go back to the start of the file. Yep. Const std is equal to import. Before import, we have to do that. What is it? There you go. Exactly. Import. There you go. Okay. Open parentheses and std string. Let's go, and the semicolon at the end. You can see the error lines, by the way, in lines. Do you see it? So that's great, right? Nice. Okay, go inside the main function, and let's make your own hello world program. So std dot debug dot print, and open the parentheses, I think. Okay, and make a string, yeah. Oh, try it. So Zig build run. Of course, make sure to save, yeah. Okay, what is the error? Okay, Zig errors aren't as beautiful as Rust, but main is not. Okay, so what is the error? The first error right there. Like, just read the error that you see, the first error that you see there. What do you think pub stands for? Public. Okay, so try run now. Okay, so what is the error? Just read it. Read it. All right. So just guess what you have to do there. Actually, you cannot really guess, but like just do a comma. So pretty much just do just do the second argument. And here you're gonna say dot and open the curly brackets, right? The curly brackets. There you go. Done. Control S. Try now. Okay. So that's your first Hello World program in Zig. So I think you see what I'm selecting, right, in your VS Code instance, thanks to LiveShare, right? Okay, great. So here, of course, we're importing the standard library. And what I love about Zig, one of the things I love about Zig, is the fact that it's very consistent. So like you don't have like extra syntax to just import a library, like standard library. You know, you just say const std, you make a constant, right? And use this function right here, which remarkably starts with this symbol right here. And this is basically all built-in functions in the compiler starts with this symbol, right? And of course you call it with one argument, which is a compile time string. And in this case, it's standard library, a CD, right? As basic as that. So we imported standard library like this, and now we have a public function main. It needs to be public so the system can call it, otherwise it cannot. And that's why you got that error. And of course we have a function main. I think that's pretty simple. This is the return type, void, meaning it doesn't return anything. And then finally, this is the body of this function where we actually just debug print. So basically we access, from the standard library, access a namespace called debug, which is by itself is import debug.zig, right? So it's importing something else, right? And we just access that namespace or that module, and we have a print function there, which takes a format string and takes some arguments. And now this kind of weird syntax is basically a tuple in Zig, and you'll understand more why it's like that later on. But for now, let's say you wanna, make a new variable. So make a new line before the debug print and make a new variable. Just guess whatever. Just try to make a, or let's say constant actually. Okay, so in use local constant. So let's say we want to say hello and whatever value inside the name, constant in this case. So we can just, okay, and great. Try now Zig build run. All right, so what is the problem? What do you understand from this? Okay, try. And there you go. You figured it out yourself. Like, I think the best skill that a new programmer can learn, of course you're not totally new, but the best skill is to just like understand the compiler pretty much. Because if you cannot understand the compiler, you cannot go too far, I guess. But basically, why this is the case though, like why it wouldn't just work like this. Try any instead. Try instead of S, try any. And see what you get. Exactly, yeah. Well, yeah. Oh crap, what? You get the same thing? Did you save? Did you save? Are you sure you saved? Oh, there you go. Okay, I think you haven't saved before. I was like, what? Did Zig change something? Anyways, so hello, and what we got there instead of that Bob string? We got basically, yeah, an array of, what do you think this is? It's ASCII codes. Yeah, integers. ASCII codes of Sam in this case, I guess. Yeah, Sam. So S is HE3, A. So basically we need this kind of any or S to tell Zig what kind of format you want. Do you want, because the thing is Zig doesn't have like a separate string type. Like everything is just like a string is basically an array of U8s, an array of bytes. That's too simply is, and is delimited by 0. So all the strings basically ends with a null byte. 0 like this, at least the compile time strings. So just like C kinda. So it would be compatible with C. Yeah. Yeah. Yep. U8 is a byte. It's 8 bits. It does. You can put emojis there. It's UTF-8. Alright, cool. So let's try something more interesting. Let's declare another constant which is going to hold a value, a number, let's say. So we're starting very simple and then we're going to up the game pretty soon. Okay, try now to print this along that, right? Let's go. Try whichever. See what the compiler says. Okay, so what's the problem you get in there? That stands for comp time, compile time. You do understand the difference between compile time and evaluation time? Runtime, exactly, yeah. You do understand the difference?
I think comp time is everything that happens before the evaluation. Like, it just already happened before the program actually.
Yeah, exactly. So that's what comp time is, compile time. And the runtime is what actually happens when you run the program. All right, so what do you think we should do here? Try something. Like you can remove that S, right? Try now. Okay, so it works. We don't need S right there because it's not a string, right? So we just need that S or any because we don't know if that array of bytes. We don't know if it's supposed to be an actual string or just like a, you know, an array of bytes, pretty much, because you don't have like a distinct type for string in Zig. They're all just array of bytes. Well, that's actually a good question because computers doesn't understand characters and strings and words. It only understands, you know, binary, so pretty much numbers, right? So how we can actually like store or represent strings, we can basically assign a code for every single character in that string. And basically, so of course we have to all agree upon that, right? So there's a lot of what should I call it, standards out there. Like there's ASCII, but it only includes a handful of characters. I think 127 characters or something like that, which of course only contains the English characters, some symbols and such. Tunify Basic, welcome to live stream. And Robert, welcome to live stream. Who's getting converted? Risco is getting converted. This will help better for formatting your string. Okay, so there's ASCII, there's Unicode, as you've said. Unicode contains much more stuff, though there is all sorts of types of Unicodes, like encodings for Unicode. There's UTF-8, UTF-16, and of course, like strings is a very big, what can I say? A pothole, I guess. What is it called? Bunny hole? Rabbit hole. Yeah, I don't know what's up with my English nowadays. Anyways, yeah, a rabbit hole, exactly. So it's wild. But like, for example, UTF. Yeah? Yeah, just continue. Well, the thing is, yeah. So the thing is about Zig, it's still a new language. So there's of course not a lot of helping hands like compared to more mature languages like Rust. So, and strings are very hard to get right. If you just check it out, like C++ standard library strings, like they're going wild. But yeah, but the thing is, what makes it a little bit harder in Zig for beginners is the fact that it's like C, where there's no difference between an array of numbers, or should I say array of bytes, and an actual, characters, an actual string, right? So there's no special type for a string in Zig. It's just an array of bytes. But like in other languages, you would usually find a distinct type for strings. Like in C++, you would find a std string. In Rust, you would find stir and string, and so on. But in Zig, what I love about Zig, it doesn't introduce new things if it's not really needed. Like here, like why have a distinct type? We can just use an array of bytes. Who cares? It's encoded in UTF-8. You need to do S to format strings. Yep, pretty much. All right, so I think if you have no questions, we can go to a more advanced topic, maybe. Zig Norton. Yeah, sure.
Can I do this?
Okay. Sure, but why? Like you created a function, yeah. Yeah, pretty much you can.
This is a different type.
Yeah, that's a built-in function, right? But that's a user function. Yep, you can. Yeah, pretty much, because these ones are the reserved ones. They are built in. Everything else is... Huh? Yeah? No, of course not. You cannot, because that's reserved for compile, like built-in functions that are built into the compiler, pretty much. Okay, so I think let's go to something more advanced. Let's see. Well, where should I go with this? Let's see. Okay, I think let's make some program. Okay, sure. Let's make some program. So let's print something first. So right now we have just used std.debug.print, okay, to actually print some stuff. But this is just like a helper function for debugging, right? But to actually print, I guess in a proper way in release mode, you have to do it in another way. So can you type this const const std out. So we're gonna get a handle to std out is equal to std dot std dot, and I don't even remember how do you do it in Zig. Let me check it out. That test std dot, well, let's just check out std out real quick. Not this, not this. Yeah, exactly. stdio get std out dot get std out, right? And then you would get a writer from it, because that gives you a file struct. So dot writer, get std out dot writer. No, dot writer, not writer, writer. Okay. Yeah, right, exactly. Cool. So now we got std out. Now we could use that std out handle or writer, right, to print stuff. So std out dot print. Okay, and just like what you have done before, to print. Okay, great. Try to run this. Okay, so what error are you getting right now?
The error that I'm getting is error is ignored.
Yep. And
Try venture if.
the note, read the note. Yeah, so try something up from that note. Just guess, whatever. Go wild.
Try guess.
Okay. No need for catch. This is not Java. Okay, try that. Try that. Let me see what. Yeah, let's see what the Z compiler does. Yeah, that's very helpful. So instead of this, you just say try before the print function. That's absolutely amazing. So just remove that, go back to what we had before. And yeah, remove that. Just a try, space, and that. Okay, there you go. Now try now. You're gonna get another error, but try. See what the error is.
Expected type void. Found error.
Okay, go to the note.
Function cannot return.
So this function main can only return void. It can only return nothing, right? So we need to tell it somehow to actually be able to return an error out of it. So we add an exclamation mark here before the type that we return, void in this case. So add an exclamation mark there. Control S and try again. Try again. Sometimes, there you go. So it works. So why we had this try here, because basically print function can fail, right? So we basically make use of this try statement right here. So if some error happens, what's going to happen is that we're just going to return this error out of this function main, right? And that's why we needed this exclamation mark. So we're basically saying that the main function could either return a void in case of success, and then error, whatever error, if some like it's disconnected. Okay, reconnected again. All right. So here actually we can, this is basically a union between a success type and an error type. So here this is the error type, right? So let's see some error, I guess. Can I find some error here? Oh crap. Well, let's get one of these errors maybe. Let me try this. Oh, crap. But either way, this is supposed to be an error type, right? But right now we can actually omit the error type and just leave nothing to basically tell the compiler to figure it out yourself. It's going to figure it out from the print function, and the print function actually returns an error type and void if everything goes well. Anyways, let's go to the next one. Though interestingly, it didn't require you to have it as variable. Interesting. Anyways, let's go to something more interesting. So let me teach you how you can make some structs. So go here, const struct, const, and name it something. Let's say, yeah, let's make a friend, as I did with with the last person. Const friend, just to go, yeah, fine, go equals to struct, right, and open the expected that, right, exactly, and semicolon, right, here's, yep, there. Right, so here you can actually define any fields you want. So a friend would have a name, right? So try to give a name there without the const. That's how you define a field, I think. And then a colon. And here the type of that name. So it's in like JavaScript where you don't have types. This is more like TypeScript where you actually have to define the types of everything. Now, a name is supposed to be a string, right? So, and strings in Zig is like an array. Well, is it really? Yeah, an array of U8s. Yeah, comma. Well, that's actually a slice, but okay. Let's go to, no, it's fine, go back, keep it. Okay, go to the next line. So that's a slice of bytes. And what we should, okay. So so every friend would have its own friends. So friends, okay, colon. And now we're gonna introduce you to, yeah, I mean, you could do it like that, sure, fine, why not? Go ahead, comma. And that's it. Okay, great. Try to compile just to make sure everything is correct for now. Okay, so no problems there. All right, cool. So now we don't need these anymore. So try to make a new friend. Const. Name it whatever you want, right? Let's go. No need for the type, it would infer it, it's kind of like Rust. So, no, just friend. Friend, and open those curly brackets, semicolon after that, semicolons after that, at the end of, there you go. Now inside the brackets, no, you have to first of all mention the field that you want to initialize, which is in this case name, right? And a colon, exactly. Okay, comma. Yeah, so just go with an empty empty slice. I'm not sure. I think empty slice in Zig is like this, but we'll have to see. Expected found. Oh crap! Did I forget how Zig makes its structs? Oh, you need the dot between the field names. A dot here and here. Okay. And Control S and try to run this. Oh, it's actually equal. Interesting. So make this equal instead. I'm still thinking in Rust right now. Okay. And let's see slices real quick. Slice. How do you make an empty slice? What the heck? Well, I think... Hold on a second. These errors aren't very helpful. Not really. That wouldn't work. But you know what? We could go with an array instead. Array list, right? So you could go with std.arraylist instead of this. Say std.arraylist. Instead of this whole thing, right? No, without this guy. std.arraylist. Do you have any There you go, cool. So now in Zig, types can be passed instead of templates and such. You just pass the type as an argument. It's as simple. So, I mean, a type is also a type, right? So the argument of this type is a type. Okay. Yeah, friend, that's... Okay. And friends is equal to, we need to create a new array list. And so you can actually put this into a constant. So you don't have to do this whole thing once again. You can just copy it, put it into a constant. Let's call it, I guess, friends. With this f. Just, yeah. Is equal to friends with the s. Okay, so the array list friend. Now say friends.init here. And I think you're gonna need a allocator there. Okay, great. So the thing is about Zig, you actually you don't have like a global allocator to allocate your memory. So like in JavaScript, you actually don't even have the concept of managing memory. Like you have a garbage collector, so you don't even care about that. In other languages like C, Rust, C++, you actually have to care about that. But you do have a global allocator there, but in Zig, you don't have that, so you have to make your own. So say const allocator is equal to cd.mem, I think, dot global memory allocator, I remember. What the heck? Oh, I think it's going to be in the standard library. My bad. I need to check out the standard library reference. Hold on. Link in new tab. Let's check the global memory allocator. Did they they change the name or something? Oh, I see. What about, oh, heap allocator. cd.heap allocator. Hold on. No. What? Hold on a second. What the heck is this? Hold on. I guess we could use the C allocator actually. Crap. OS. Why the heck I couldn't find it? Oh, actually, my bad. General purpose allocator. So cd.heap general purpose allocator. cd.heap general purpose allocator. With the, yeah, exactly, but without the config. And is it a function? Okay. Oh yeah, gotcha. And then what we be doing here? Gunnar Chorson, welcome to live stream. I'm trying to teach Vrisco some Zig. I think it's probably like this. Though I do remember this guy being a bit weird. Oh, it needs the config, my bad. Okay, so it's a function and it needs config. General purpose allocator. The LSB suck. Okay. What's up with this? Maybe, what the heck? Hold on. Yeah, it's this. All right. .config. In use local great. Okay, hold on a second. I'm trying to refresh my memory on this one. In use local great. Okay. So now I think I could use it. The allocator. Right. But no, actually I have to instantiate this. And then okay, so this is the GPA general purpose allocator and GPA.allocator. So this is our actual allocator. Okay, great. So now we did get an allocator. Great. So you can pass this allocator there in the init function. Don't worry about the general purpose allocator for now. Okay, great. Now try this. Try to compile this. Remember to DNit. Yeah, sure. And used. Okay, so so we can DNit as Robert said. Let's actually put this into a constant. Put that into a constant. Into a constant. Yeah, we'll come to the variable, right? No. Take it out and make a variable outside. Okay. Yeah. Okay. All right, so after that, say defer. No, before Tom, just after you init, you have to de-init that array. So after that, a new line, defer, that ss, right? Dot de-init. Okay, so let's slow down a bit, I guess. So here we got the general purpose allocator. This would basically help us to allocate memory. Std.heap general purpose memory general purpose allocator, and here we're just passing a normal config. So like you can actually configure the allocator here however you want. Like, oh, the LSB suck. Okay, anyway, never mind. Actually, we can actually see here. Here's the link. You can see the documentation. So there's all these properties that you can actually change. But anyways, let's go back. And we basically instantiate a new type of this general purpose allocator, because this actually returns for us a type. And this is actually how you do generics in Zig. You're probably not understanding this, but trust me, I'll understand this in a second after we get to it. But here, we're basically getting an allocator. So the thing is about Zig is that we don't have interfaces like Java. Does JavaScript have that? I don't think JavaScript have that. Well, like Java, for example, have interfaces. Rust have traits and whatever. But in Zig, like C, we don't have that. We just use vtables. Oh crap! You're a JavaScript developer. I just remembered. Okay, interesting. I should have probably not gone that fast. It doesn't have memory allocation either. Actually, I probably have gone too far already with this. I think let's slow down a bit and make it a little bit simpler for now, to be honest with you. So I can actually teach you some more concepts before we go to the advanced way. Because I just realized how much stuff I'm going to be teaching you in one burst, which you're probably not going to understand anything. Okay, so I guess let's start with something simpler. Make a new struct, okay, called vector. Yeah. You could build an example with Zap, making it feel familiar to Express, for example. I think libraries would be a bad decision to add right now, especially that libraries in Zig aren't that stable. But okay, cool. UH or like you can actually go with F64, like float. This is basically what you would have as float in JavaScript. F64. Why? Yeah. Go. Yeah, make Z, I guess, too. Why not? Or this is fine. All right. Whatever. Yeah, sure. Add Z. Sure. Comma. Okay, so how we can make first of all, try to make a new vector. Try to make a new instance of this vector struct. Okay. In Zig, the naming convention is like this. Snake case. Okay, semicolon, and add, initialize X and Y. Of course, make sure to add the dot before the field name. Okay, dot y is equal to, great, and dot z. Okay, maybe call this A, and copy it and make a B. All right, great. So we want to add these vectors together. We can declare a new function. No need for public, because we're only going to use it for now here. Add, okay. Just try your best guess. So this is Zig Day. Yeah, welcome to the live stream. It's gonna be a little bit of a bad day for me because I didn't program in Zig for a while now, and it's constantly changing. And the great Zig LSP also helps too much. But it should be fine. All right, let's see what we got here. Okay, great. So try return. And you would return what? Okay. Feels rusty. Yeah, it's Zig is like, you know, Rust and C had a baby. That's exactly what Zig is. Return vector, create it. Okay, go ahead and just go on what you were gonna do. Fine.
I'm thinking there might be a special way to add.
Yeah, just try your best guess, and then I'm gonna try to.
Okay. So I think we need to declare
I should introduce him to that rather. Yeah, I'm just trying to, like, if you've seen my previous video, I try to not give the best solution at first. I start with a pretty primitive solution, then we go up the ladder and we introduce more concepts. I mean, you could just like initialize the x and the y of the new result vector. Here, just do it here. Just like you have done here. It's exactly the same. No, you create a new vector. So like a plus b would create a new vector.
Oh yeah, I mean I was just thinking like I don't know if I want to add.
Yeah, dot x is equal to okay. I mean, you could just do the calculations here inline.
Really?
Yeah, dot x is equal to what?
X equals a dot x.
Okay. And okay, great. And you don't actually need a new variable for this. You could just return the vector directly. This vector instance that you have made instead of a variable. No need. I mean, it would work, but no need for it. Okay, do Control S so we can format it, hopefully. I think you gotta add a trailing comma and the formatter would do the job. Add a trailing comma here and save. Save? Okay, good. Alright, so try to add, now use that function to add the vectors together. Okay.
That's like actually returns. I mean I don't have to.
Const C, for example, or whatever, yeah. Great. And now try to print that. .debug, .print, yeah. Okay. Add the tuple, the Zig tuple, great. Run it. And
It's not exactly what I want.
what happened there? Hold on a second. So vector is a struct, not an object. But yeah, you could call it an object too. Okay, so why we had this? Hold on a second. What the heck? Did I miss something? A.x, B.x. I mean, they should be fine. What's going on with this huge? Or is it huge though? I think it's correct actually. It's just a weird formatting, I think. Yeah, it's just weird formatting, my bad. Yeah, pretty much, I think. Yeah, it's just weird formatting. Let's see. All right, so right here, here's some little tips to improve. So the compiler already know that you're going to return a vector from the add function. So as Robert said, you can just replace this vector with a dot to tell the compiler to figure it out. Here. There you go. Control S, make sure that it works. That it still works. Okay, cool. Right, so now the thing is, you can also do another thing. Instead of making this add function in the top level, what you can do, you can also like put it inside this struct right here. Just copy this, cut it like, and put it inside the struct declaration here after the fields. Okay, great. And now instead of a, let's go with self. Call this self. Hello, Theo Paris. Welcome to the live stream. Yeah, instead of a, we just replace with self. Okay. So now what we could actually do, instead of add a comma b, we can right now do some sugar syntax and say a dot add b, just like you would do in JavaScript object, I think. Okay, try now. Make sure this works. Always it's on the iteration. Great. Okay, cool. So the other thing that you can also do, kind of like Rust, but I don't think you know Rust. But anyways, you can actually make a constant value wherever. So here, put a const, self with a big S, right? Capital S, const, is equal to this. It's a built-in function in Zig. With the big T. There you go, exactly. Semicolon. So what this would do, basically, this is a built-in function in the compiler that would give you back the type that this constant is defined in. So in this case, it would be vector, right? So you can, instead of right now using vector, you could use self. If anyone is coming from Rust, they would understand. There you go. So that's, I mean, that also, the other way also works, but this way you can easily change this vector struct name and you don't have to change it anywhere else. So that's pretty good, right? So now you just have to add it where you use it. Clean this one. Hello, Travis Taluk, welcome back to the live stream. I do remember you from a long time, from I think the Zig Vulkan streams. Hello, const self is an anti-pattern for simple structs. All right, good. Yeah. Okay. 2G. Why is it an anti-pattern? Though I do remember such a thing before when I was programming Zig. 2G replace is the go. Okay. I'm on my alt. My comments on my other accounts aren't working. Why? And Aurelian, welcome to live stream. Because someone said. Okay, so as you can see, you even changed the name easily. You didn't have to change these because they're already self-typed, right? So in Zig, you know, you can store types in constants, right? Without any problem. So a type is also a type, pretty much. And there you go. Okay, so the other problem that we have here is in like JavaScript, where you can use like whatever type you want. In Zig, that's not the case, because here you can notice that we have F64s, floats, or actually doubles if you're coming from C family languages. So how we can make this generic? Now generics in Zig is very interesting actually. In like other languages, which you would use templates, generics, it's very natural. So here's how you would do it. You would actually, Well, let's make a fn new function first, or init actually. It's called init. Fn init. Let's go. Did the link get censored? Oh, maybe it did. You can, hold on. Yeah, I probably have disabled links maybe because of spam. I'm not sure how to, but you can send the link in my Discord server, and I can, yeah. All right, so this init function, you could basically, you would get x and y and z, and you would initialize a new variable of this, sorry, a new instance of this class or struct. All right, so just get some arguments x, y, and z. f64, comma y, f64, okay, z, 64. And now just make a new object out of those arguments. Just like we'd make a new instance, right? Return dot. Yeah. There you go. Send a link, okay. Where is the, oh, it's in the Zig server. Okay, gotcha. I see. Right, in this kind of code, there's no need to declare. Just use the struct name. Why? When it's self-needed? I know, okay, but what's the problem? Yeah, I know that's kind of suck when you cannot do it with nested structs, but but like it doesn't say why it's problematic. Yeah, it's not necessary, but it's actually quite convenient. Like I've said, I only have to change it once, and that's it. Like, especially coming from Rust, for example, we already have this self as built in, but in Zig you don't have that as built in, so you just have to declare it yourself, basically. But yeah, like, if someone can give me like a real problem with it, then yeah. But honestly, I prefer this way. Okay, great. So you have done it. You have initialized the new vector. Nice. So now instead of doing this, try to create a new instance using that new function that you made. Okay. Hello, Hats. Welcome to live stream. How's it going, man? Not new. You just say in the struct.init. Does JavaScript also use this new? I see. The problem happens in time scope and return structs. Yeah, I think the art says that it sacrifices readability. How often do you need to paste the code around versus how often do you read it? I think, yeah, I found this actually more readable, to be honest with you. I think it's pretty much subjective, I guess. Well, GG Kieran, welcome to live stream. Okay, so what's the error that you got? Type main dot nothing, does not support array initialization syntax. Huh? Did you save? What itself? You have to scroll up for context. I mean, if you are at that point, you already know what is the struct that you're working with. I think you are given the context that you're working with particular struct. It's okay, yeah. Okay, so what's up with this guy? Hold on. Stick build run. What the heck? Type main nothing does not support. Oh, okay, I see. So here you have to actually make use of dodge. Dodge equal to, right? So just like what you did here. No, not there, not there. here, up there in the initialize function, init function. The y, it's just syntax, I think, just syntax of fields, in this case at least. The x is equal to x. The x is equal to x, right? Here. Equal to x, right? And here and there, right? So that's how you initialize the struct, just like before. And yeah, there you go. So save now, try it out. Returning, yeah. Okay, so what's the error? Unused function, what? Are you sure you have saved? Okay, there you go. Nothing. Alright, so that works right now. So instead of having that top level function, we have that. So now let's actually make this generic so it can work with any type. Instead of just floats. Because if you try to work with, let's say, integers, it wouldn't work. So here's how we're gonna do. No, that's not gonna work. Okay, so we're gonna make a function, new function. Totally agree. However, is teaching someone maybe many other words considered idiomatic zig. Okay, fn, and create a new. What should we call it actually? Yeah, call it nothing. Call it a nothing as you had before. Just like what you had, like this, literally like that. Okay, and you know, declare a function. Go ahead, continue. Yeah, it would be better if you called it generic vector. Or vector, just a vector actually. Vector should be fine. So just change this to vector. Vector with a big V and vector here. There you go. All right, so now here we're gonna return an anonymous struct because we can't do that in Zig. So return a dot to infer the type of the vector because we already declared that. And here, hold on, what the heck I'm saying? Actually, no, struct, return struct. So here we're actually going to construct a new struct. Actually, it would return a type here, sorry. I think, yeah, pretty much it would return a struct. Type, yeah. Haven't programmed in Zig for a while now. Okay, there you go. Now, enter, and then here you would declare these fields that you have declared before, X, Y, and Z. And now, yeah, just declare as it was, right? Okay. So we're just going to basically rewrite what we have done now, but just in another way. All right, cool. And then just, you know, copy those functions that you had before into here. Okay, great. All right. Oops. Try to fix the formatting there. Or Control S. To keep the Zig community happy, let's remove self. Remove it. Or actually, don't we need it here? I think we need it here because this is gonna be, it's an anonymous struct, right? Yeah, I think we need it. Yeah, just leave it anyway. Never mind. We're gonna need it here. It's not just convenience, I think, here, if I'm not wrong. Try to compile this and see what's gonna happen. Let me check out the reference. Generics return struct. Okay, great. So what it said? Did you run it? Okay, great. So that's cool. So, all right, but hold on. Actually, let's remove the nothing that you have done before. The struct that you have. Yeah, there you go. Okay, so that's why. Okay, so you need to call that function vector now to get the type. The type doesn't have to have a name, you know. It can be, it's just anonymous in this case. So you call that vector to get back a type. Now this is in compile time. So this function would kind of run a compile time to give you this struct, right? This anonymous struct. So you should call it. You should actually call it, because it's a function now. It's not just a struct. It's actually a function that returns a struct. That returns a new type, basically. Or you could even right now say const. But before that, actually, so just run this actually. Just run this. Run this now and see. Okay, what's the error? Oh yeah, you should have this. Yeah, you haven't completed that. Yeah. Okay. Cool. All right, run this. Okay, so as you can see, it works. And now notice that the actual name of the struct, the anonymous struct that we have just made, is main.vector. So anyways, so that's how you basically do the same exact thing, but with a function. But now what's the difference why we would like to do this like this is that we can actually pass some parameters to this function. So make a new parameter in this vector function called, what do they call it in Zig? Idiomatic? Okay, T, sure. Comp time. Okay, T. And what's the type of a type? So this is supposed to be a type. What is the type of a type? It's a type. So just say type like this, because here we're also returning type. So say here type, yeah. T, no, T comp time T of type. T colon type, right? Okay, so here we're passing the type at compile time. That's why we have a comp time here, right? And now we can actually use this T type here instead of F64. Instead of F64, use the typeception, exactly. I love Zig generics. I just love like how a language can be so simple just by like basically not introducing new syntax for no reason, like just reuse stuff. Like instead of having to do struct, you know, just reuse that const x equals struct, you know. Like why? Just why? There you go, Zig does it. The function takes a parameter and that parameter needs to be known at compile time and it's type and it's named T. Yeah, exactly. Okay, so what's the, oh right, so the problem that you have now, what is it? Read the error. Yeah, so what you need to put there, in your opinion? What do you think? Yeah, just try. But like you need right now an actual type. You need to pass it some type. Like, let's say F64. Pass in F64 there. Instead of T, F64. Oh, I think he's AFK for a second. Okay. Alright, that's fine. You need to pass a concrete type here. F64, for example. Not type, F64. Okay, and F64 there. Run this. And it works. So here what we have done. So this function right here, this vector function, returns an anonymous type, right? So the return type of this vector function is a type at compile time. And it gets a compile time t, which is also a type. Now here we're returning struct. Remember when we had here, instead of t, we had f64? Now instead of having f64, we actually passed the t type that we have, that we got from the function as an argument. And we put it here. We use it here. So here what you're doing is you're making a new type where the x and y and t, x, y, and z are of type, yeah, it could be any type. You see? So instead of vector f64, to make it more readable, you can make a constant, const. And let's say f64 vector or number vector, or I don't know, call it whatever you'd like. Make sure to follow the name convention. It would be, since it's a type, it would be, what is it called? Capital case here. Pascal case, yeah. Pascal case here too. That's fine. I'm gonna, yeah, there you go. Okay. And here, just remove that type. Here, just say vector f64. Call that function. Okay, there you go. Now, instead of vector f64 every time, it would just say number vector. Though it doesn't matter, like this is the exact same thing that you're gonna do right now, because these typed functions in Zig gets memoized. So when you call it with the same type again, it doesn't generate new code, you know, it returns the same thing, same type. Anyways, so there you go. That's exactly the same thing. It's just a bit more readable, you know. So here you use this vector function to create a new vector where its components are of type f64. You see, there's no special syntax here for templates or generics in Zig. You just pass the damn type as an argument. As simple as that. like the first time I've learned Zig, this like totally blew me away. Yeah. All right. So, what do you think, chat? We should go to next. Maybe make instead of XYZ. I mean, we could have a vector of any size, right? We could have a vector 4, vector 3, vector 2, vector 1, right? So instead of, we cannot do XYZ anymore. I mean, using Zig comp time stuff, you can actually do that. It's very powerful. But let's not go that way for now, right? So instead of XYZ, what do you suggest we should go with to store all the components of some length? Why, by the way, did you remove the add stuff? Can you go do Control Z? Okay, good. So just what do you think should we do instead of XYZ to store an arbitrary amount of elements? We can use an array, pretty much. Right? So array, not list, array. But we could call it components. We could call it components, vector components. So components, right? And the type would be an array. So it would be okay, do an array type there. Okay, and instead of u8, what you should do there, we have a generic type. Yeah, exactly. So remove that thing here. Semicolon, not semicolon, comma. And there you go. But that's actually not an array, that's a slice, which have a length at runtime, not a compile time. And it doesn't own its back in memory. So, I mean, it could be what you want, but in this case, we don't want that. We want an array. And an array, you can actually tell it how much elements, I think, here, if I'm not mistaken. Try. Okay. Does it work? Say zig build to make sure it compiles correctly. Actually, it wouldn't anyways, so we still have to do the other stuff. Okay, never mind. All right, so instead of, well, let's keep this as 3. Okay, do 3 there. Let's start simple. Let's not use generic just yet for that. Okay, and right now change your code to make use of this component's array instead, because we don't have x and y and z anymore. We have an array. So remove these other ones first. So, okay. And declare that array. Right, there you go, okay. Yeah, go ahead. No need for that. Just curly braces. Yeah, and what you need to initialize that array with in this case for now. X, Y, and Z. This is an array, so X, Y, Z. Yeah, exactly. See? Oh, I think you missed here the type, I think. T. Okay. But I think you could probably use a dot here to infer the type, to let the compiler infer the type, maybe. Try it. Remove the T, because you have put dot instead there. Okay, try now. Actually, you still have to change the other code, right? So change this function to add. Yeah. Like Zig have the most consistent syntax that I've seen. Self. But no, just like do it just like what you have done here, and you just are gonna add the components together. Or actually, what you could do, you could just use your init function here. Instead of making a struct, you could just use your init function. Actually, yeah, you need to loop over, right? My bad. Okay. Okay. So make a new struct. Now you're gonna need the variable, right? So say var result is equal to var result is equal to, and declare that to be self. Let's say there's a lot of ways to go about this, but let's copy self, right? Semicolon, sorry. Actually, yeah, good. Go ahead, components. Okay. Or you could just say, yeah, go with self, just self, it's fine. I mean, we could do both. Yeah, self, there you go. Now you're gonna loop through that array. So we need the for loop. Just try your best bet real quick with for loops. Okay. Yeah, I'm just always curious to see how people would guess it. Not really. So Zig is a modern language, so we don't need all this crazy. My dude is like you're- components, just result. It's in this case result. Yeah, for result, remove the components. Okay, for result, and then after here you would make two pipes, like the or, two pipes. Here, no, yeah, exactly, but here, put it here. Right, and here you would say, I guess components? No, hold on, result.components, sorry. Right, and then say here component. So you're basically gonna get every component from that array here. Component, no, without the dot, just component. Okay. All right, so now what you gotta do here, you gotta do component plus equal. There is a problem here, but let's not spoil just yet. Just say component plus equal. And plus equal what? B, yeah? B what? Dot? You also have that array components. So what you gotta do? Well, now the problem is you need the index, right? Now there is a better way of doing this, but let's go solution by solution. So you can make an index by making a range here, comma, and a range there. 0 dot dot. This is how you make a range in Zig, unless if they have changed it already. But yeah, do a comma here and capture that range. So it's going to be index, right, of that array. Index. Call it index. Yeah, that's what you call the variable that you're iterating through. That, right? So now you can use that index here. There is a better way of doing this, but let's go step by step. Index. So I can teach you the language. Okay. Semicolon. And then finally, what you're gonna do after the for loop? Great. Exactly. Okay, try to run this now. Or do you see an error already? Local. Interesting. What do you understand from the error? Yeah, it never gets changed because here we're actually just changing the copy of the variable component that we're getting every time. So we're not actually changing the result array itself. So to do that, we have to take that components array by reference. So instead of taking a new copy of those components, we take a reference to it. So say here ampersand, put an ampersand there, and a star here. And I think you should do dot star to dereference. Do you understand pointers? I don't think you do, right?
Well, pointers, my understanding is that there's like there's a place in memory with the value, but variable doesn't actually hold the value, it just references.
Yeah. So, yeah, exactly. So like a reference, you don't hold the value, a copy of the value. It's like, let's say you want to refer to your friend's home, okay? So you're not gonna take a copy of your friend's home and that's going to be another copy, right? And good luck copying a house, first of all. So what you do, you actually take the address of your friend's house, right? And when you want to go to your friend's house, you actually have to refer to that. But what you have there is an address. So what you should do for that address, you have to resolve it. You have to dereference it by basically checking out where that address points to, like what it leads you to, right? It would lead you to the house, right? So after you dereference it, it would lead you to that value. So here we're actually dereferencing it and saying plus equal b dot components index. Okay, try see if this works by any chance. Okay. What is the error? Type does not support array initialization syntax. Yeah, the same. Oh, hold on, no. Type. Try T here. Okay, save and zig run. Oh, okay. There you go. It worked.
So why is that?
We just changed, instead of XYZ field, we have changed it to, an array of 3 elements of type T, right? And here we just created a new copy of self. And we put it in the result variable, right? And then we loop through, or we iterated through the whole components array of this result. And though we did by reference, so we don't copy the elements, we actually refer to the original values in the result itself by basically making a dereference operator here and a reference here. Right, and also we needed the index so we can also access the b dot components. So we got that too. And yeah, there you go. That's how you do it. Though there is a better way of doing this. You can, instead of 0 dot dot, you can also say the same thing as you've done here, but with b. Try it. The same exact thing, but with b. No. The same exact thing as this, but instead of result b. Oops. No, keep that, the original one.
What do you want?
Copy it over and put it in the second one. No. Hold on. Okay, it's like, no. Copy this thing, right here, and put it here. In the range, instead of the range, put it here. Yeah, copy it and put it here. But you forgot the % here. Oh, you have removed that. Yeah, exactly, B. So that's how you, and here what you should do now. So now you're not getting index anymore. You're doing the same thing as you're doing here. Okay. And they missed something. B component, sure. And now what you can say here. Actually, you don't really need by reference. You know why? For the B at least. Are we mutating B in this case? So we don't need the reference. You can just remove it. Okay, there you go. Now you don't need this. What you gotta do, so we're actually getting the actual components right now of B. So instead of this, what you should do, plus equal what instead of this? You're already getting the B component, and you're not getting the index anymore. You're actually getting the B component directly. Exactly. There you go. So save it and run. Okay, there you go. Same thing. But right now this is way more hygienic, I guess. There you go. So we took the result components array by reference because we needed to mutate it. We needed to dereference that reference to mutate it directly, right? And we didn't need to take the B components by reference because we're not mutating it, right? And notice that we're not actually, at least in this case, we're not mutating self itself. We're actually mutating a copy of self, which is result. Because when you assign in Zig, you actually take a copy of that value. Right? You understand right now? Do you have any questions before we go further about what you have done so far? So we can go to more advanced. Ah, I see what you mean there. But the thing is, copying just, I mean, it depends actually on the T. Yeah, it depends on the, if it's like just F64, that's pretty cheap to copy. And actually it would be better than like taking it by reference and then dereferencing. Because dereferencing, you have to look up the address, right? We can't hear student's voice. Do you guys have the same problem? What the heck? Oh my god. Why did you guys didn't tell me? He wasn't hearing you this whole time. Oh my god.
Oh no. Hello everyone.
Crap. Guys, why didn't you tell me? Alright. Can you please introduce yourself again? Oh
You can call me the Briscoe. I am a JavaScript noob.
Oh my.
And I like interesting concepts. I'm also an artist. And now I'm trying to figure out why Zig is the best thing of all time. And solve problems.
Alright. Oh my god, bro. Anyways, thank you so much. Who's that? Sudeep Pujel for telling me. Oh my god. I see pro Zig programmer here. Okay. I'm so sorry guys. I forgot completely to activate the audio of the student. Oh my. Well, that sucks.
That's okay. This is only the second time that you've done this. It's fine. It's fine.
All right, it's fine. All right, let's go.
There'll be hundreds of more students.
Sure. Okay. So, we were talking. So basically, what he asked me. Can you actually repeat your question?
It's a hard question for me to ask, but I was basically saying like figuring out why we don't reference it when we don't manipulate it, and why we do reference it when we do manipulate it. I understand that you reference something to save either time, speed, or energy, because you don't want to do a whole copy of like a large thing. And maybe we don't reference B components because it's not like we're saving time or energy by referencing B, since we're not mutating it anyway, right?
Yeah. All right. So you understand the first part of why we need the reference, because we need to mutate it. Good. But the second part is, it's actually a really good question, and I actually have missed it. So the BDO components, he basically asked, why don't we actually also use the reference here? Because with my own analogy, instead of copying the house, we're just gonna copy the address of the house, right? And look that up. And the thing is, so here it depends on the type T. Is it cheap to copy or not? So at 64 here, it is cheap to copy. That's a very little type, and it's like how much bytes? It's just like 4 bytes. Yeah, is it? 8 bytes, sorry, it's 8 bytes. It's just 8 bytes, so it's not much, it's very cheap to copy. So here, this is fine, because here we're actually not copying the array, or are we? Yeah, probably we're not copying the array. We're just copying the elements inside the array, right? One element after the other. So this is actually better by taking a copy for every element. This is better for F64 because it's a cheap thing to copy. It would be much faster than taking a reference, then looking up that reference. Because you see, when you have the address of your friend's house, you do need some energy to actually look up from that address to find where the house is, right? So you do need to figure out where the house is. So that also takes time. But if this was actually a bigger type though, that is not cheap to copy, then yeah, that is true that we also want a reference here, although we're not going to mutate it. But we don't want to copy that big type, right? So I'm not sure if there's an idiomatic way in Zig of figuring out if a type is cheap to copy. We have that in Rust with traits, but I'm not sure if that's the case. I mean, we can do some metaprogramming in Zig, some crazy metaprogramming, but I'm not sure if there's an exact idiomatic way of doing it. Okay, so yeah, you can, since this is a generic vector, we don't know, at least for now, instead of going through, you know, some crazy metaprogramming, let's just go the safe way, right? And just go with the reference also with the B components too, just to make sure that we don't copy a big type, right? But okay, try it. Hold on, let me save. Control S. There you go. Try it. But we have a problem. You know why? Try to figure out what the problem is.
Compatible types F64 and const F64.
Yeah. So what do you think is the problem there? We have changed something, right? We have changed this to become a reference. So what we need...
So this needs to be referenced as well.
Exactly. But you don't dereference it like that. You dereference it like this. There you go. Try now. Oh.
Incompatible type. Wait.
Huh? Hold on.
Did I save it right? Hang on.
Yeah, make sure to save. And there you go.
There we go.
So this is... Right now we're actually, instead of copying every element, we're actually also referencing the B components. Pretty much.
Nice. Okay.
Is there any other questions for now?
Not about this, no.
Great. So what about if we want to make this length of components also generic and also a compile time? Just like T, what we have done here. Can you figure it out how to do this?
Is it another struct?
Not really. I mean, how did we remember? How did we added this T, this generic T? Where did we start with that?
In the function for vector.
Exactly. Yeah, what we did. What we did
Comp
for
time T
type, right? So
type.
okay, so you add a new argument here.
So this one is for length.
Yeah, it would also be compile time, because this is an array. It should be, the length should be known at compile time. And let's say n. Let's say n. And the type of this, it wouldn't be type. What this would be, yeah, that's a good one. But I think, is it usize? Okay, so the usize is the best for this for an array length, because it's basically, it's the size of the largest that you could, that you're, well, what can I say? The largest addressable size, I guess. Like this type allows you to store as much size as your computer can address, basically. Either way, usize, right? And now, yeah, exactly. Good, n. And where we should change that again?
Here.
Okay. Where else? Is there anywhere else? I don't think so, yeah.
Yeah.
The only problem though we have is with our init function, currently it's still assuming that it's XYZ. So here what we
No
should
idea how to
get,
fix this.
we should just get like components, right? Components array directly and put
Just
it
like
here.
one array.
Yeah, pretty much. Components, field, right? Go ahead, components. What the type of this array? Just like here.
N2.
Okay. And now what
And
you need to
then-
pass here. Dot components equal to what? Components.
Components.
Yeah, pretty much. There you go.
Then that's it.
Yeah, pretty much. That's it for the initialize. Now what you gotta do here, instead of that, I mean, we could also
Init.
use a tuple, but there's no need, honestly. So yeah, go ahead, init, and what you would do here, what you would change here to create an array. You basically need to create an array here.
Braces, maybe.
Yeah, first of all, remove this. No. Go down. Yeah, there you go. Here. Okay, so what you should, how you make a new array? Yeah. So here's, okay, go ahead. Yeah. Yeah, there you go. Cool. Okay. So expected type expression found. Oh, so don't you need something here? Yeah. But what is t in this case? Number Vic. What is the t of number Vic? No, like what is the t of number Vic in this case?
Vector?
No, what is the type of the elements of this? What did you type here?
Oh, F64.
Exactly.
F64.
There you go. So right now you have just created vector 4. Let's go. Try it now. Zig build run.
The vector 4.
Zig build run. See if
They use vector 4s in
Did you save?
Vulkan.
Ah,
I did not.
okay, save.
Sorry.
But what's the problem?
So the 2 arguments found 1.
Why?
We need the length.
There you go. But now what would be a better description for this? Exactly. Let's go. Let's go. Run this. Try to run again. And there you go. You got your vector 4. Try now a vector 3.
Can we fix the output?
The output? Like how? What do you mean? Like you...
Well, you know, because in the output it's like kind of these 1.67 E1.
I honestly do not remember how to do that. Hold on. Let me check the reference if I can find something about that. I can always... I honestly do not remember how would you do that, but I'm pretty sure there is a way to do it. That's correct.
There was something earlier that we did with making letters into numbers, you know, ASCII codes.
Oh, no, that's irrelevant. That's irrelevant. That's for strings. No. Anyways, so what about a vector 3? Let's make another instantiation for this, which is a vector 3. Const. So here you're making a new type again. Let's say 64, sure, okay. Comma. All right, there you go. Now use vec3 instead of vec4.
Just do this.
Yeah. Okay.
3.
Run this. And there you go. That also works.
I've made my very own vector
Generic
type.
vector in
That is
Zig. So didn't you notice
wow.
that
So
this is
now I can do a
yeah, this kind of sucked that you have to always change this you know, this number right here. So you can actually do it just by changing that number to what is that called? Underscore. Try underscore there. And here too. And now you basically tell the compiler to figure it out yourself from here. You're smart enough. And yeah, you can also do just dot instead of this whole thing. Instead of this whole type right here, you can say dot.
Dot is also infer this.
To make it even, like to make the compiler infer the whole thing, right? And there you go. Now Zig build run. Boom.
Perfect. Amazing. Interesting.
Okay.
Nice.
Great. Can we actually remove this in Zig? I think so. Yeah, we can. They are optional as long as you have one statement. If you have multiple lines though, that is not optional. Okay, great. So what should do next?
Can I remember to use dot, asterisk, ampersand, and asterisk before the variable name?
Honestly, I would just keep it since we do not know what t is. Like, is it like cheap? Like, is it cheap to copy or not? But let me check out the standard library of.
Why are they all
Zig.
different though?
What do you mean?
Like, sometimes you use ampersand, sometimes you use asterisk.
So this is to actually declare that you're gonna take a address of the variable, right? And here you dereference it. I'm not sure why exactly they make use of this kind of syntax, but there you go. Is there any other question? Let me see the meta library if we have some cheap copy stuff. Cheap. Copy. Meta. Maybe is primitive. Oh, there is primitive, I think.
Yes, I do have a linear algebra library.
Right now, this can take weird types, like you can pass an array type to a vector function. Try to limit to floats and indices in comp time block and assert. Yeah, pretty much. There is this primitive return true if a name matches the primitive type or value, exclude the integer types, names like short syntax. I see. So there is an is primitive function in the standard library, std.zig.primitives.is primitive. So we can make use of comp time here, I think. I'm not sure. I've never done this before, but I guess we could try it. So go to, I don't know if I want to go through this trouble actually. But let's try it. So let me try, I guess. If std.zig.primitives.is primitive, and it actually needs, this is a rabbit hole, exactly. Let's just see if it's too deep. If it is, we're just gonna bail on it. So I guess here the name of the type, right? What name is being used here? I think it's the name of the type. But why it doesn't take a type though instead? That's weird. Is primitive. Well, I guess let's try it. So we can actually take the type of, well, we already have T, yeah. We can actually take the name of this type. I don't think, honestly, this is good, is it? Why it's taking the type? Like a name instead of the type directly, but anyways, so we can actually take the name, a compile time, the actual string name of the type. This is called reflection. And let's see. Does Zig requires? I think so, yeah. Okay, so if that is the case, if it is primitive, then we can actually remove this reference stuff and remove this too. Else, actually hold on, yeah, good. And maybe I do need to say comp time if or something like that. No, maybe if comp time. I do remember something like that. Hold on a second, let me see the reference. If I mean, let's just try it. Who cares? Or we could maybe say inline if. I think that's for for loop though. No, yeah, it's for loop. Anyway, let's just try this out and see what happens. Zig build run. I mean, it seems to be working, but if it is really working out as expected, I don't know. But I would honestly, since this is generic, I would rather like not copy a big type than copy a big type but make it good for primitive types. So you just take the least damage, I guess. So I would honestly just go with this. But either way, notice that here I could even take the type name of the type as a string, right? and pass it to this crazy function that does its own crazy stuff at compile time. So it's wild, in the Wild West when it comes to compile time stuff. That's Zig. I love that. But yeah, this should be good. All right, should I teach you some memory? I don't know, man, if I want to go that direction. But do you have any
input?
Oh, sure. Okay, so like what do you want to make, for example, with this vector using user input?
Vector user input. Okay, what do we have? So we have right now we just have a type that we have a type vector.
Okay.
We have an add function.
Yeah.
I'm thinking, just.
All right. Let's say we want to take input from the user. Sure. Let's start from there. Make a calculator.
Wait, can I add a subtract function first?
I mean, sure. Try to do that. Just copy paste, right? It's that simple. And minus.
And that's it, right?
Yeah, pretty much. You can
so like maybe we can say, do you want to add or subtract, and then.
So that's what you would use for lambda, but I don't think Zig have a lambda, though you can do some interesting trick that I've learned a long time ago when it comes to Zig using anonymous types. So here's the thing. Let me see, because I don't remember exact. It's been a very long time since I've done this. Self, I guess other is better for this context. Self and self, right? And it would basically do this thing, right? but we cannot do this anymore. You can just say, and here we would get, let's say, some function. How do you do functions in Zig? We don't need this right now. Hold on. I wonder how to do lambda this in Zig. I remember I've done it using anonymous structs, I think. Let's see. But is there like function pointers actually? Of course it would be, but like where is it? Hold on, function pointer. Oh, okay. Or prefix with const. Let's go. So we have this.
Are we doing a high order function?
Exactly. I'm trying to, but I don't think Zig have lambdas. But we could use function pointers or anonymous structs. Like, yeah, let's start here, I think. So this is a binary function, but actually, yeah, sure. But let's make it a function so we can actually generate this thing, right? So, and we would basically return a new type. Return this, and we would make a comp time t, I think, and we would make this here, and yeah, maybe binary function here, and we would call this with the t that we have, and use of undeclared, yeah, other here. And now maybe we can call this function f, this component like that. Not sure if this would compile actually, but let's make a little function here and call it, I don't know, add, too simply, and let's have some a. Let's just say 64 for now. B 64. Now let's return a plus b, too simply. Don't we have add here? I don't know. Anyways, okay, cool. So let's say component y is b comma add. Can I do this? Is this legal? Let me see.
No.
Let's see if this is legal or not. What? Clear. Zig build run. Missing parameter. Yeah. Comp time type. Huh? I think it worked, right? Right? I think it did.
Well, we did. Yeah. Well, no.
So if I said sub instead.
Yeah.
I guess it worked.
It's saying 0.
Oh yeah, makes
sense.
Makes sense, right? So that works actually, yeah. So here's what I've done pretty simply. I've made this function so I could generate a type of a binary function of any type. Right?
What is a binary function?
A binary function is a function that takes two arguments, the two operands, right? So left and right, and gives you some value out of it, right? That's
okay. And then you put that function inside the.
So plus is a binary function, minus is a binary function, multiply is a binary function, divide is a binary function. But like for example, though, what is it called? Yeah, minus, for example, minus 10 like this is a unary function. Minus is a unary function, right? So it only takes one argument, right? So if you have fn negate, right, you would have some value x f64, and that value would be just like minus x, right? Sure. But of course, it
Yes.
doesn't make sense for this function to get a unary function anyways. It only makes sense for a binary function in this context, because this is a component-wise operation, right? So we just take whatever function f that is binary, of course, and we just use it here. So instead of saying plus, equal, or minus equal, we just take a pointer to a function, you know, const fn, a, b, and of course here I'm assuming that that function gives us back the same type, because I don't know if Zig does have such a thing where, yeah, yeah, sure. I mean, you could easily make a function that, let's say, I don't know, takes a f64 and b f64 and returns you know, usize. Like, I mean, that could happen, right? So if you really want to support that too, you can make another type, because the way we have done it right now is that this should be the same exact type. But if you want this to be more flexible, to have like a different return type, then let's say you would say u type, right? Then it would return u instead of t. And here in binary function, I mean, in this case it would be just t, because we're not taking in another type, right? We only have t. And there you go. So yeah, pretty much. Is there any questions on what I've done here? So right now, instead of making, you know, a new function for every single of these operations, right? You would basically make this one function component-wise that would do some operation f, whatever it is, and it would, you know, like do it on, apply it to on the vectors, right? Component-wise.
That's really smart. That's too smart for me.
Nah, it's like just takes, I guess, practice, especially if you're coming from C and stuff. And in fact, there's vtables that I wanted to explain before, and it's basically function pointers, a structured function pointers, and that's how interfaces work in C and Zig. But that's a bit more advanced, I guess, for now.
Okay. So now I can. Does that mean I can remove?
Yeah, you can remove them. There's no need for them, pretty much. And there you go.
And you have sub though. You have sub out here.
Yeah, but there is a little trick that not a lot of Zig people know, which is you can actually make a, you know, you can make a anonymous struct in Zig, right? So you can make a function inside of it, right? I mean, Zig doesn't support lambdas, but you can do something like this, right? So fnf, let's just take this, right? And I mean, you could call it whichever you want. What do I need here? What the heck? Hold on. What's up? Expected comma after initializer? Huh. Oh, my bad. Struct here. So we're making an anonymous struct, which inside of it is a function. Let's call it f, I guess. And shadows local. I see. Shadows this. It doesn't like that. Interesting. Let's say AABB. Okay. And now, here's the big move. So I created an anonymous struct with a function called f. I could just access that f function from the anonymous struct and pass it in. There you go. You have lambdas in Zig.
That is just crazy.
This is the power of like making your syntax this flexible. It's just amazing.
I didn't know the power of simple.
But honestly, I don't know
languages.
why Zig wouldn't allow, wouldn't make lambdas really. It's a very important thing in 2024. Like, instead of doing this monstrosity right here. So yeah. Is there any
Well, I guess I'm as.
Is there any other question?
Let's delete this.
Okay.
STD, no. Const
STD
STD
is equal to, right?
equals import STD.
Okay.
Pub nothing main exclamation mark void because we want it to be able to return errors.
Exactly, yeah.
I want to do a. Okay, so for output, I'm going to say std const std out equals
Okay.
standard IO get std out.
You can check out the reference also of Zig if you need that, yeah.
And then for input, it'll be the same, except in.
Try it. Okay. And just make an echo
So I wanna do
application. Whatever you take in stdin, output it into std out.
Okay.
This is something we do when we're
Okay.
making servers. It's called the echo server. Whatever you give it, it gives you back. It's the simplest server I guess you can make. But here you're not gonna make a server, you know, you just have std out, stdin. Try to figure out how to get some data from stdin and basically give it to std out directly. Try to also use the reference if you need that. And autocomplete a bit.
Maybe const. We'll see in JavaScript, it would just be like, oh yeah, just const user
Equal input.
input equals just, you know, alert. Nah, prompt.
Yeah, front.
What is your name? But it's different here. So
Of
it would be
course.
like st.
Here you manage your own memory.
Actually, I want to output something first. Oh wait, do we have to do like a buffer or something?
Probably. Check out the
Okay.
reference.
See, I don't know how to do a buffer. Okay.
It's actually not that easy, actually. But I mean, maybe you could figure it out in the reference using the standard library reference. So here's the standard library reference. Check out the stdio. So search for std.io. What is that? Get std out. Okay, and see what that gives you back. So it gives you back a file, right? And that file is basically a struct which contains a handle. And check out the file documentation. There you go. So what is an stdin and std out? Std out is just a file, right? It's like Linux, everything is a file.
Yes.
So check out the documentation to see if you can figure something out. Whatever.
Okay.
Just see if you see something interesting there. Although, to be honest, this is not that easy.
So you want to do std and
You remember when we took the writer of std out?
there's a
What about you try that?
there's a okay const. Is it a const writer?
Yeah. Well, like you could just take the writer directly here anyways, I guess. Or you could go that way, sure, fine. Writer, yeah. Okay, cool. And the reader. Great. So right now it kind of like you got the interface of a reader and writer. You're not handling any more files, right? So a reader or writer, it could be a reader to a server, it could be like a reader from a server, a reader from a file, a reader from whichever, who cares? Kind of like interfaces, right? So I guess you could check out right now the document. Yeah. Check out the reference maybe of writer and see. Where's reader? There you go, reader. It actually gives you i.reader. Okay, here's the reference. I'm gonna put the link right now. There you go. Here's the reader, and see the functions that you have there. Actually, there's a clever way of doing this, because otherwise you're gonna need to allocate memory. But there's something interesting that you can do, but there's no way you will figure it out.
If I want to do reader.read, I need to do self and buffer.
Or you could actually use a for loop by reading 1 byte at a time. Is that even possible?
Oh, that's like C.
Yeah, you could do. You do have read byte. You do have read byte function in the reader, and in the writer.
Well, okay. Here's the ultimate. So are you saying that we should do a program where user inputs something and it just repeats what they
exactly input? Just an echo program.
Just
echoes, exactly. It takes whatever input from the reader, outputs it to the writer. So in the reader there is a function called read byte. Let's try that. So we're gonna do a for loop, and every time we're gonna keep on trying to read a byte from. Let's start there.
How do you do a for loop again?
Who remembers? For reader. Well, here you're actually going to use another kind of loop, I think. Let me check out on the reference for the while loop. Hold on, where is it? My bad. So while. Where is that while loop? While true. Back what we're doing right now. Right now we're trying to make just a little echo program that basically takes whatever it gets from std out and outputs it into std in or input into the output directly. Okay. This is not eventually. Oh, there you go. Okay, so I guess maybe try to say reader.read byte, I guess. Try it there. Yeah, exactly there. But instead of for loop, while loop. But the thing is about read line, I think that needs allocation. We're trying to do it without allocation, and I think that's even simpler maybe, and more efficient, I think, if it works. So while reader dot read byte, so gonna read 1 byte at a time, and you would capture the byte. Yeah, good. Byte. I'm not sure if that's honestly correct how it's done. No, I don't think you need to reference there. Yeah, just try to print right now. Just use debug print real quick, just so we can debug this, see if it even works.
This is two arguments too, right? Boom.
Byte. Yeah, byte. Put byte here, so we can print it. Yeah, and you need some format here. Some placeholder. No, you need some placeholder here for where the byte would be printed. Exactly. So try now, terminal. Of course, you got an error, you forgot something, which is there you go. Cool. Go ahead.
Try.
Okay, what is the other error now? Expected optional
Byte.
type found error. I see. Gotcha. Okay, let's see what the error type. So this only works with optionals, but we have a result here basically, right? So let me see what kind of result that is. Hold on. Where's that thing? Oh crap. Where's the documentation? Reader.
Read until delimiter or end of file.
I did send the documentation, my bad. Alright, so where is that read byte function? It returns either a UH, which is a byte, or an error, which is no AOF error. End of stream. I think I think there's or else and what else? Oh. Yeah, there's this or else function or if operator. If A is null, returns no. A catch error, B catch B. Oh yeah. No. Try read byte, maybe catch, or else for optionals, not error unions. Yeah, catch. Can we do catch null here? Just remove the buffer. We're not gonna use the buffer.
Hold on, I got this. I got this. It's real quick.
Okay.
Try read dot no. This will. I think I have it. Oh wait, this needs to be that. And then you have result. I think you can say
Yeah, now just remove that read byte because you have used something else now. Okay.
yeah. I think it should be right.
Or you could use a writer.
Oh, writer. Let's see. Writer
Try.
dot print.
Format. You wrote.
Then result. That might work.
You need to try
Gosh.
before the writer.
Oh.
Okay, what's there?
Cannot format optional without a specifier. Oh, question mark. Question mark?
Because the result is an
Unlock.
optional. But you don't want to actually print the result, you want to print what's in the buffer. The result is like, I don't know, maybe the error.
So I don't want the result?
Yeah.
Oh.
You want to print the buffer, what's inside the buffer, not the result.
What if I do...
The result is how you check, I think, for if it worked or not.
Okay, so if we're going to check...
No, just keep what keep what you had. And instead of results, say buffer. Okay. And so the Zig compiler doesn't complain. We could just say we don't want to use that result for now. Okay, try now.
Okay.
Oh, result is the length of the data. Okay. Okay. You wrote hello and all that
And then
in the find memory, I guess. Yeah.
okay, so that's okay. So it's okay.
Try again.
Okay.
Try again. Clear and let me clear.
I think what happened is because I wrote 1024 at the
Try Zig build
the
run
size.
again. Okay. That's good. Alright, so it actually works, but you're also printing the undefined memory that is left in the buffer. Printed the whole buffer. You can use buffer.
Cut that.
Yeah, as Hat said,
that
you could use buffer result with the range to take a slice up to the result. But you need to check for the result first. I think it's optional, right? Yeah, it actually returns the error, which you have already enwrapped. And it also returns an optional file. So you just got to check if result as you did before. Go on. If
result.
Well, the parentheses. And you capture the value inside of that because it's an optional. You unwrap it from the optional, you get the value back, which is going to be our how much bytes have been read. Okay, and now take this print function there. No, just take this print function there.
Take it.
Yeah. And here, you just say colon. No, leave it as it was. Just say colon after it. And that value. Sorry, you need this guy. You say colon here. And then that value. Try that. Expected expression, huh?
Set it into file.
Interesting. That should be 0. Oh, I think in Zig you actually do it like this. Yeah. There you go. There you go. Okay, try this.
Okay.
Expected type.
Expected type usize found array of U8.
Huh. Interesting. Let me see how you do slices again. In Zig.
See, I think.
Crap. Where's the slice stuff? Slices. Yeah, it's 0 point dot dot. Yeah, why it doesn't work? Try again. Zig build run.
I've done this, but it didn't.
Zig build run. Huh. Expected type usize. Oh, this is what? Hold on, what this actually returns? It actually returns the bytes. Ah, I see, the byte slice, my bad. Gotcha, so this is the actual bytes. So just print it directly, right? Try now. It's not the, yeah, it's the slice already, yeah.
It's a slice already.
Yeah.
Please subscribe. It didn't repeat it. It didn't echo it.
Try again. There is a problem, the bug with the Zig printing without the new line and such. Really? Hold on. Did you add the new line here? No. Maybe we need a new line to flush the output.
Hey.
Oh yeah, there you go. Try now.
Okay.
Try now.
Nice.
Yeah.
That works. So it was looking for new line. When it didn't find new line, it didn't say anything.
Yeah, that's actually good, but the problem with this way of doing it is the buffer is limited. That's
Right.
why
So
I
you were
wanted.
doing a different method.
Yeah, I was just gonna be reading. Now there is a way better way of doing this, but I just was trying to make a primitive way of doing it. I don't know if, let me see, yeah. I'm not sure, does it work? Well, reader.read byte, catch null byte. I mean, you can do something though, I guess, which is like, you can use that buffer to take some data after the other, but let me just see if this would work by any chance.
Ad says it was looking for flushing.
No, it's not flushing. It's just that it's printing the raw bytes here. So can I do this maybe? There you go. Okay, so you would say no C, because this is the byte, not the string. This is we're taking one byte after the other. And so instead of this, we could just say try ladder.print. But of course, this is actually bad because we're writing one by one. We're not using the buffered writer, which would actually use a buffer. But there's even better way of doing this that I'll show you in a second. Print byte. There you go. Oh crap! What? Yeah, see maybe. What's up? Expected tuplers. Oh yeah, I see. Tuple here. Hello, and there you go. Welcome back.
Infinite.
To another. Yeah, it keeps on taking bytes and printing them back to you. That's an echo. There you go.
And this is better.
But there's actually a better way of even doing this. So
I can't believe it.
We have a reader and we have a writer, right? We can use a FIFO. Though I don't remember how I did this. That's been a long time. Let's see. It's in the standard library. It's called FIFO. Std FIFO. Linear FIFO. Yeah. Okay, let's try this. Hold on. Std FIFO. Linear FIFO. Let. I think it's probably gonna be var, but let's start with const anyways. FIFO is equal to std.fifo.linear FIFO. The type is U8 bytes. The buffer type, linear buffer type, static, dynamic, or slice. Let's go with static. This is basically what kind of storage you want to use. But I'm gonna use static storage, and I think how much bytes you want to buffer. Since this is static, maybe, and then I think I need. Yeah, here I'm actually creating the type. I think, and then I have to init. Or isn't it? Yeah, the LSP here where it sucks, because there's some comp time magic happening there. I think. Hold on, where's init function here? Is there even an init function in the first place though? It doesn't look like actually. Maybe I just have to, like what this actually returns, hold on a second. It returns a type. I mean, maybe this is it. Actually, hold on. I do remember there was like it was something that would just reads and writes directly. Or maybe it was just FIFO. Oh, I can right now say init here, I guess.
It's file input, file output.
There's an init function here, yeah. Cool. But why it didn't show it here? That's weird. Ah, this LSP suck. Anyways, let's sig build run, see what's happening there. And use local constant, sure. FIFO. Let me make sure I'm using this correctly first of all. Cool, so it compiles. Now let me see what kind of functions I have here, because I don't remember the function. I think pump, yeah. Yeah, there you go. Pump data from a reader into a writer. Stop when reader returns 0 bytes. AF buffer size must be set before comment. Buffer length of 0 is invalid. Yeah, I think it's probably FIFO dot pump. And you give it the source reader, which is reader and writer. I think that's it. But I think this should be var, right? Yeah, it takes the reference self. Maybe? I mean, let's just try const anyways. Cargo R. Zig build.
Hey, cargo.
Okay, note parameter. Found const. Expected type FIFO. Oh yeah, so let's make a variable actually, yeah. Consider using, try, I think here. And there you go, it works. So this is the best way to go about this. Try it, because I think.
Why is this the best way?
Because it actually buffers. It does exactly what I've done before, but it also uses the buffer. It makes a buffer of 1240 bytes, and it buffers the data, and it keeps on, you know, pumping from the reader to the writer without allocating anything. With using the buffer as a way to kind of like batch data, so you don't keep on reading and writing 1 byte at a time. You read 1024 bytes and write 1024 bytes at the same, like, basically. Try it. Zig build run. It's the exactly same thing, but this is the best way to go about this. When you have a reader and a writer, you make a linear FIFO. And there you go. That's basically it. You pump from the reader to the writer using a buffer 1024.
Okay.
There you go.
All right. I mean, hey, it's all more complicated than JavaScript. I will say that.
So yeah.
All right. Well, how would I store an input to a variable?
Well,
Can I pump the reader to a variable?
no, then you don't need a FIFO then. You wouldn't need it. I mean, you could probably use a FIFO here, maybe? Or is it? Yeah, you can actually read the data into a destination slice, read item. Hold on, readable length.
I have a quick question.
Why I wanted to use linear FIFO exactly here, because we already have a reader and a writer, so we can easily just pump from one to the other directly. But yeah, there is some functions that you could use to actually do that too. There is to own slice and update writable. What is the question, by the way?
You were going to do like an HTTP server, like what you did previously with Tokyo and Rust. Would you use pump for that?
For like to make an echo server, yeah, you would use that. You would have a reader from the server, from the client connection, and the writer would be your std out, let's say, or something like that.
Yeah.
But of course, a HTTP server is way crazier than that. And the one that I've done with Rust is actually asynchronous and multi-threaded in Rust. So It wasn't an HTTP server. I think, yeah, I just made a little messaging application. But there you go.
Some cord. It was some kind of protocol.
Not really. It wasn't. It was without a protocol. We was just using telnet to communicate messages. Just
Okay.
text messages, pretty much. So yeah, you would first of all log in. Not really log in. You just tell the name that you want to identify as, and it can tell like it gets you in, right? The raw no,
Yeah.
no, it's not raw. Using Tokyo in Rust, pretty much. Is there any other questions?
No.
All right. Okay, is there any other program you want to make now?
Well, yeah. I mean, to expand on this, adding the input to a variable.
Sure. So we can use
Um,
FIFO for this too. I mean, we could just use the writer directly actually for this. But you know what? The problem with gonna be the reader. Yeah, let's use FIFO. Why not? Because this gives us a buffered writer. But we could use a buffered reader directly instead of a FIFO. FIFO is the best when you have like both writer and reader. You see? That's why I thought about a FIFO directly. But I think you could use a buffered reader too. Make it calc with your vector class. It's the vector class is already gone. Yeah, read.
I'm making something much greater than a calculator.
Reader. Okay, so you can make use of buffered reader instead of FIFO too. Like writer.print. Okay, try to make a buffered reader.
Is that like the one that I made before?
No, var or const. Let's start with const. Yeah, type in. No, just keep those. Yeah. Okay, const a buffered reader.
PR.
Okay, equal. It's stdio.buffered reader. Buffered reader, and the. Hold on a second. What? No way. No. That's not. That's gonna suck. Hold on. Let me see the writer. Sorry, stdio reader. I guess. I think that may have some way to give us a buffered reader directly, or isn't it? Interesting. Because this would require the reader. Oh, my bad. So you just pass in the reader there. Yeah, just pass in the reader, and yeah, and then you get a buffered reader. And the buffered reader, you could use it to read right now. This does exactly what you have done before. You created a buffer, right, and such. That does it for you, for the performance benefit, because reading 1 byte at a time is not great. br.read, you could use read, and that actually gives you an error or how much bytes you have read, and then you need to give it a destination, a slice. You can make another buffer.
Another buffer.
Okay, buffer. But hold on, that's gonna have the same problem as before. Interesting. Well, we could use the reader. We could even allocate memory for it. That's a choice. Read all alloc, I think. Oh, there's a lot of crazy functions here. Read. Actually, you could make use of read int, maybe. What this does exactly? Comp type Indian. Try that. Do you want to read an integer or? Yeah, I just want to read a string. I see. Okay. Well, we gotta look for how to allocate using this. I think it's probably what you want is read all alloc function inside the reader. Read until delimiter. Alloc. Yeah, what you remember what function you were using before? Read until delimiter.
Read until delimiter or EOF.
Now you just gotta add alloc because the problem that you had before, you were using a static buffer, which of course you can only get as much with that. But now you could actually allocate memory dynamically. So buffer is equal to, yeah, buffer is equal to, instead of this, let's just remove this. Well, use your buffered reader, I think, or maybe this already does that for you. I'm not sure, but to keep things simple, let's just remove the buffered reader, honestly. And let's just use that, yeah, fine. So here you're gonna need the allocator. Yeah, you can make the allocators const GPA, which is general purpose allocator, equal to std.heap general purpose allocator. Yeah, okay, and here the config, you would just say dot like this, just like that. It would infer the type, and it would make use of default values. But before that, you cannot pass GPA. The thing is there's a lot of allocators, and each allocator have its own type. So you need to take an interface of allocator, right? So come here and say var allocator is equal to GPA dot allocator. And this would give you back, hold on. Yeah, you should actually instantiate this type because this would return the type. Right now it would work. So now you have an allocator. Now this function allocator gives you back a struct of function pointers. It's basically a vtable. It's called a vtable, virtual table. Or a dispatch.
Struct of function pointers?
Yeah, it's basically an interface, but you do the hard work yourself. Like it's just, I mean, the language doesn't help you. Here it's just a struct of functions. You can actually say control and press on the allocator, and you would see that it's just a pointer to self with a vtable of the functions of that allocator. This is the way we do run this dispatch at runtime. What is that called? Runtime dispatch? Yeah, runtime dispatch. So like, so instead of like using generics, you know, to allow for any allocator to be passed here, we use runtime dispatch by just storing function pointers to the allocator. So like you could use GPA, you could use any other allocator, as long as it can give you this dispatch table, you're good. So, okay, so you pass in allocator here and delimiter. What is delimiter? I think you have done n before, right? That new line for delimiter, right?
Yeah. Yes.
Yep. Go ahead. And the max size, why max size? Interesting, weird. Shouldn't need a max size. Shouldn't need a max size.
Well, it can be that one maximum
yeah, sure.
referenceable size.
Like maximum. Yeah, this is what you want to do actually. std, hold on, dodge. Do I even remember how to do this? Math, I think it was. Okay. Oh, I think it became oh, okay. But no, not this. Weird. Because the thing is about, yeah, there's this F16 max, but I think it's deprecated. Use float max F16 instead. Ah, I see. Float. Oh, well, what do we want actually here? We want size of, actually. Size. Int size. Well, was that float size? What the heck? Hold on. What is this? Use float max F16. What is that? Float max. It's in sct.math. So instead of this, we would say int max, I guess. Why it doesn't show? What the heck? Is there no int max here, or the? Maybe it's int. What? Int? No. Max int. Okay. std max int. Let's go. And then you would actually say usize, I guess. But I'm not sure if this is how it's supposed to work, really. And use local constant. Alright, so right now you got the buffer, you can print it, I guess. But before that, what this returns? What this function returns? Can you hover over it, see the signature?
Read until delimiter.
It returns a slice, but it's behind an optional value, and it's also behind the result. So first of all, I need to try here. And second of all, it is also optional. So you can make use of an if condition. So you just wrap this in an if condition, just like before.
This?
No, I mean, there's no need for this variable, right? Yeah, exactly. So you capture the value, and the value would be the bytes. The value would be a slice of the bytes.
Like so.
Okay, I think you got an extra here. No. Okay, try to print there.
I'll just print. I was gonna do like const x equals bytes.
Expected statement. Weird. Okay. I'll just say bytes directly, no? Say bytes directly instead of xy. No need for that, yeah?
Statement found semicolon.
Yeah, you don't need semicolon there. There you go. No need for this.
And the allocator is never mutated.
Ah, because it's just a function pointers. But the GPA, I think, should be variable. Okay, go ahead. What is the error? Cannot. Okay, you know this one.
Yes.
Yep. Clear and redo
It didn't print.
because when the zig compiles, it just F up.
It's still.
Oh yeah, you didn't add a new line, don't you? Or did it? hold on.
Wait, boom, boom. I got it.
Okay. There you go.
There we go.
Yeah. You need the new
All
line
right,
to
so
flush. Right. So now you could use that bytes to do whatever. That's basically you have allocated that. But we forgot one thing though. We didn't de-init the allocator. Or do we have to? Yeah, we do. So here we're gonna do so like we could do it like this. We could say GPA dot de-init like this. But the problem with this is the fact that GPA is right here and when de-initializing it at the end of here. So like they're not in the same spot, you know, and you can easily miss it. That's the first thing. Second thing, if an error happens and you have exited prematurely from the function, then you're not gonna reach the statement, so you're gonna leak your GPA. You're gonna leak your allocations, the memory that you have allocated, because unlike JavaScript where there's a garbage collector to take care of your garbage, in Zig you have to take care of your own garbage. Right, so instead of doing it like this, we can actually say, come here, say defer GPA dinit, and the compiler would actually run this now whenever this scope exits. Whenever the function returns with an error or without an error, it doesn't matter.
Okay.
And yeah, and this would also return a check. This would also return a check to tell you if there were any leaks or not. So you can actually check it out. So like, we can just say std.debug.assert gpa.dinit is equal to dodge either leak or okay. Let's make sure that it's okay. Assert that it's okay. And now if there's any memory leak, it's gonna tell us. And in fact, there is a memory leak here, I think. Let me see. Yeah, there is a memory leak. There you go. It actually crashed. I don't know if it. Try it yourself so you can see the error clearly, because I think there is a bug with live chat, live share terminal when I run it myself. Okay, try, and it's gonna crash at runtime. Read the error. From the start, error.
It's a failure. The following command.
No, like just after your input, what it said.
Memory address leaked.
Yeah, because when you de-init, it actually checks if you leaked anything. And here we're actually checking, and if that happens, we assert and we crash at runtime. That's why it reaches that. Okay. So you know why? Because this bytes right here, we're actually allocating it. We're allocating how much memory we actually need to fit in the input at runtime. So unlike before, we have made an array like that is like fixed size at compile time. When you have an allocator, you can actually like set the size at runtime. And that's why we can actually resize this allocation however we want. Like it can be as long as the input. It doesn't matter how long as the input is, right? That's why we need an allocator. But of course, you gotta make sure after you're done with your bytes, after you're done with the memory you allocated, you have to, well, let's say we print bytes, right? And you just say defer bytes. Well, actually, allocator.dinit or destroy. Good question. It's probably free. Yeah, it's free. Free bytes to free that memory because you don't need it anymore. And here I'm just saying defer. So after this scope ends, it would destroy that bytes. Let's see if now we get the leak. Try. We don't get any leak right now Because after the end of the scope, we actually remove our garbage. We free it. You see?
Right. I see.
So why we need allocations?
We need allocations because we need to be able to free, just have a specific place to free memory from.
But like, why not use a buffer instead of an allocation? Instead of allocating memory? Why not use just a fixed buffer?
Because it's dynamic.
Yeah, who's dynamic? What is dynamic?
The amount of memory allocated.
Yeah,
Or
you can set it
used.
at runtime so it can be as long as the input.
Yeah.
But when you create an array, as I said, or a buffer, it's fixed at a compile time. You cannot change that at runtime. So it cannot accommodate the size of the input.
All right. I understand.
Okay, is there any questions?
Maybe I have one more thing that I want to try.
Sure, what is it?
Randomness.
I'm not sure
So there's.
how to do random.
I'm looking at the documentation.
Oh yeah, there is a way to do randomness in the doc. Try it.
Okay, hold on. So what I want to do, that's the last thing, is have a program that takes an input as a seed and then outputs a string based on the seed. It's like a pseudo random. So that way, if I input hello each time, it'll output the same string of characters.
I see.
If I input bye, it'll output a different string.
Okay, try it.
So the input, what the user inputted is the seed. So it would be, I guess, bytes, but also just, to call it, we can call it the string. I mean, the seed.
Sure. But that seed is a string, not a integer. So we need to convert it.
Yeah. Is that how it's usually done? So we need to cast, right?
Not really cast. You have to actually convert. Because cast is just like you have a type, and you easily just reinterpret it as another type, kind of. But like conversion, you have to actually go through every character in that string and build a new number, build a number out of it. So
what type do we want to convert it to?
I'm not sure what's the most idiomatic way in Rust, but there is something called std.fmt.format. Renders fmt with colon writers less. Okay, or we could just search Google and see what you get, because I don't remember honestly.
You can parse int, right?
Yeah, check that out. Let's see the documentation. Parse int. It's std.fmt parse int. There you go. Check the documentation. Let's go. That's the link.
Parse int takes 1, 2, 3 inputs.
Well,
Comp time type,
yeah.
Which we need to figure out, might be.
Well, basically, there's a lot of types of integers. Which integer you want exactly. Yeah, just choose whatever integer. Like the integer.
I'll say use 16.
Sure. But then you would only be able to parse integers up to 65,000, I think, or something like that. So it depends on how big that integer is. You can only store as much as numbers.
You know, some languages have 512 byte integer or bit. I have 512-bit integers.
I don't think so, but you can like
Yeah,
there is languages that would use
that's
the heap instead of doing
I
that.
know.
They would actually use the heap to store as much digits as they want to like infinite. Well, not infinite, but
I know
like as much memory
Python
as,
does that.
yeah, exactly. Python does that. In Rust, you have a library. I would guess Zig also have a library for that. Though, to be fair, Zig you can also you're not limited to U16, and I'm not sure if it works with this. But in fact, in Zig you can do up to something around 65,000 and so on. There is still more, but that's what I.
Wait, what is usize again? Like, what does usize do?
Usize, it's gonna be U64 in this case because we have a 64-bit CPU, and 64-bit CPU can only address as much memory as 64-bit. Though
Okay,
it's
yeah,
less,
let's do that.
it's less in practice. It's less in practice than 64 bits because of some constraints on the operating system and such, and memory mappable stuff. But whatever. Anyway, just choose whatever integers really. Okay, go ahead.
What would be the buffer? We don't have the buffer, right?
We do have a buffer, which is the bytes that we want to convert or parse. But
Okay.
you don't have bytes in that scope, so you have to put the seed inside of there. There you go.
Now the documentation says base is, well,
Base is like
base?
the actual base number. So is it a decimal number? Is it octal? Is it hexadecimal? Is it binary number? So a binary number would have a base of 2. A decimal would have a base of 10. So what kind of integer you want to parse? A decimal. So 10. Base of 10.
Base 10.
So now try to print
So
that. See if it works.
I think that is seed. Seed build run. One error. Cannot format error union without a specifier, so exclamation point.
Now, what it's saying,
point.
why you do need that, because it is a result, so it could be an error. So what you should do here.
Try.
Exactly.
Try.
Yeah. What?
D9867.
That's why you need
Decimal
to try
98.
there. Because it could be an invalid integer, which she said hello. It's not a base 10 integer.
That's correct.
Yeah.
Oh.
Okay, so it's up now. Invalid character still.
Is it looking for one character? If I do this.
What? Weird. It's saying invalid character. Maybe the new line is included there? Try to... Yeah, can you print the bytes here? but not the S, the any. So bytes and here any, just to see something real quick. Oops, what happened? Oh, the we're trying to write at the same time. Okay, there you go. Okay. Yeah, I think the new line is included there. So what we're gonna do, we're gonna do minus like, hold on. So I'm gonna take a new slice out of it, which is gonna be from the start. I think like this, no? No, like this. Okay, so from the start up to the end, -1. So bytes dot len -1. Actually maybe -2 really. But let's see. Oops, what's up? You can use local. Okay, seed. Let's see now. Okay, that works now. Try it. So I just basically not included the last character, which is gonna be a new line. Oh, actually, it should be like this maybe. Try now. There you go.
So that is our seed,
Yeah.
which looks the same as the bytes. But okay, so after you have the seed, it would be like we need a random number
Generator.
from that.
So check out the
So that would be
documentation.
random.
Random. cd.random and prng Xoshiro. This one at least I know it. This is
Default PRNG
interesting.
right there, and under the types.
Read random bytes into the specified buffer until full. Interesting. So you need to create this random thing, random struct, but how do you do that? I think you probably select one of these, maybe? Let's see. Try say const std.random. Const random, of course. What you got there? Do you have an init function maybe? I don't think. So I think you just actually have a field ptr, which is any opaque, which is like void pointer. Weird. Okay, hold on. Let's just search Google. Zig random. You can. It seems like you could just say maybe a cd.rand.random.default prng. Or in fact, there's also rndgen. Yeah, that's basically a cd.rand.
I think I almost got it, but I have an error.
Huh. What's the error? Expected
Following
type found.
command.
Yeah, because this should be a variable. You see the pointer is const there.
Oh yeah.
Okay, try.
Local variable is never mutated. So it should be like a. So now it wants it to be const now.
Yeah,
Or-
it should be const. This one should be const. I see. I see. You gotta actually, since this should be mutable, you should put it in its own variable. This thing right here. Yeah,
So okay.
that's your generator.
Var.
And then you use that right there. Okay, try now.
Okay. Is that working, or let me try again.
It did, but you're not. You're just generating some random thing, but not like a random integer or random whatever. Got the point?
I think it. If I do like my name. Okay. Yeah. If I do 10, it'll do that.
Is that
20. It's doing like a random hexadecimal. No. Yeah. It's generating a random hexadecimal code.
Yeah, but what if you
The
set
part-
dot boolean here, for example? Try that. Because that gives you a struct random.
Now it's just saying. Now it's just echoing again.
What the heck? Try again. There you go, false. So this gives you like a random struct.
Well, I wasn't trying to make a random number, just like a random string of characters.
Okay, so instead of a boolean, you probably need something else. There is a fill function, which you can give it a buffer.
Is it going to say false every time? No, it doesn't. Okay. Be true or false. All right, integer. There.
Yep.
No.
Expected one argument. What kind of integer? Because it's a comp time t type. Well, you only say comp time in the type in the declaration, right? Not in where you actually do the value. Here, just say the type. The type that you want. Which integer kind? What, yeah, exactly.
Again. 10.
There you go.
Try again. 11. It is different, and then 10 again. It's the same. All right. That's it.
There you go.
It works. Now the length of the number is determined where?
What
Just
do you mean by the?
it's just 0 to the max int, right?
Yeah, it's like depends on how much bits you have here. So 2 to the power of that bits. In term when it comes to inside -1, I think. So it's 2 to the power of 64. You know, like -1, I think. That's the maximum gonna be. Or what you could easily do actually. cd.math.max int. Say the type. U64. Try to print this.
Struct argument. Trying to comp time int.
Expected. Oh yeah. We gotta make this into a tuple. No. Oops, what the heck is that? Hold on. There you go. Try now. This should give you the maximum integer for that one. We're probably not gonna have in a new line. Try now. That's the maximum right there in the end of for U64. You can try some other type and see the maximum there too. But you probably can find some library for Zig that would give you
255.
from 0 to 255. There you go.
All right, well. You know,
That's cool.
that is pretty much what I wanted to make.
Yeah.
Of course, next time we can make a reverse search where I would enter a number like this, and then it will say what the seed is for that number.
I think next time we're probably gonna deal with some data structures. Make WASM 4.
Yeah, that is really
like some.
That's super complicated. It's basically have you heard of the library of Babel .info?
No. What's that?
It's a website where it's basically like the concept is that it's every book
Yeah.
that could possibly exist. And what they do is they have like, every book has like a code, and you can kind of just enter the code. And okay, so it's like not okay, how do I explain this? It's a website with every book that's possible.
Yeah.
Which means that everything that we've said here on this stream is in that website. But that's just because it basically has every string that is possible, and you get to those strings through codes. But you can also reverse search. So you can say my name is Kodotaku,
Okay.
and it will tell you which code that book has. So it's like both ways. You can use the code to get the book, or the seed to get the book, or you can write the book text to get the seed.
What is the link? Babel.
It's library. I'll write it in the chat.
Okay.
Library of Babel.info. You don't see it?
No. In the chat Discord, I think.
All right, I'll write it in Discord.
Or I thought you were gonna put it. Okay. All right. That's weird.
So there you can go to, like, of course, there's browse and search. So browse is when you type the code, and search is when you search through the text.
Yeah, my brain is. I've lost it right
So
now.
just like do anything. Just like you can either enter the name yourself, or you can click one of the options here. So just like write any string.
Yeah, but what is this?
So
I typed
so
hello.
this is you're exploring the library now. You've went to the floor that is the hello floor, and now you can go to shelf 1, and then click one of the books. You have dark mode on, so it looks different, and there's that book that's in this section of the library.
Weird.
That's the title, and that's the text, and this book will be here forever. You can always return to this book.
Okay, so I
And
guess
then you
hashes.
search.
Is that just hashes?
I don't know if it's just hashes. No, it's I don't think it's
I
hashes
mean,
because
given the
only
same hash, you can
there's
reach the same data, but like you cannot
no
get from the data
because
back to the hash.
no, because if you go to that code, you can reverse it. So you can see the code of that book, or because with the hash, it 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 doesn't go both ways.
Not sure I understand.
With a hash,
But I can look
okay, so
into it.
basically,
I can look into it.
yeah,
I need some time to
yeah,
read through this and
it's
see.
it's it's very deep. This is and with a hash, you can have the same code for multiple, files. So it's not the same.
I see.
In this one, you only have one code per book.
I see.
Yeah,
Wild.
it can be complicated.
Yeah. So yeah, I think
But see,
this is it maybe.
what you can do is what you
Yeah.
can do is you can go to search.
Search.
You can hit the search button under browse, and then type something that I said here. Just like type anything.
Search.
Yeah, just
Or let's be more creative, I guess.
so basically what you see now is yeah, okay.
Okay.
So the first book is a book that only has the word Kototaku. The second book is Kototaku is in there, and the third book is Kototaku with other English words. And you can see the codes there, the location of each of those books. And then there's the next book with only the title, which is Kototaku.
Does this have any practical use though?
No. But see, there's so in the blue text, there's the
Yeah, there you go. Good attacker.
yeah.
Anyway, I have to read through the theory.
In the blue text there, that's like the location, so you can reverse search it by going to that location and get the same book.
Nice.
So it's a really cool algorithm.
Yeah, I'll surely check it out.
Yeah.
But yeah, maybe next week we can, or any time you have free time again, we can do this. Pretty much. This weekend though is full. Like I have some other people that will come in.
Yeah.
After that, we can maybe do another video on Zig, or stream on Zig. Pretty much. That was a lot of fun. Kind of had a hard time because I didn't program in Zig for a while now.
Now we're both Zig experts.
Yeah. A Rust programmer and the JavaScript programmer become Zig experts. Zig basics experts.
Exactly.
But we actually haven't touched upon like crazy advanced comp time stuff and reflection. It's just wild, man. Like you can generate actual types really easily. I mean, you can do that like in Rust, for example, but it's hard, bro.
Wow.
In Zig,
Well, I cannot wait for
very
Zig
natural.
1.0, man.
Yeah, it's like 1.0 would be crazy, yeah.
It's gonna replace every programming language ever.
Not Rust, at least in its own high level stuff. So my plan is to use both. Zig for the low level
Okay.
and Rust for everything else.
Don't you have on your Discord your top 5 programming languages?
Yeah,
You have somewhere, right? Like I saw Rust was number 1, Zig was number 2.
exactly. Where is it?
I don't
Hold on,
remember the rest.
disable. Yeah, my weapons ordered from the most preferred. Rust, then Zig, then C, C#, Lua, Python, Java, and C++. And hello, Trey2K. Welcome to the stream. Oh crap, he became a supporter? Didn't I disable that? Thanks. That's interesting. By the way, Trey 2K would be live with me, I think tomorrow, right? What's today? Actually, no, after tomorrow, Sunday. Yeah, Sunday. Hello, Trey. We're just ending the stream. But yeah, Sunday, Trey 2K would actually show me, like, onboard me on his open source project on GitHub, C++. It's a Godot Lua API. So that would be very, very interesting. Although it's in C++, but I can take it.
C++ is perfectly, you know what? I never got too advanced in C++, so I don't know why people don't like it so much. It's fine to me.
Well, like when
People say it's
you
complicated.
see, when
Sure.
you know Rust and Zig, it becomes a bit harder to to program in C++. But I still come back to it, especially CPPCon talk. It's very, very amazing stuff. Prefer C.
Yeah, maybe you would.
C++ is a bit bloated, to be honest. Yeah, I also prefer C. But now, if you know Zig, though, if you know Zig, it would replace C eventually. The thing is about Zig, what is different about the other languages that wants to replace C is the fact that instead of, like, you cannot replace C, but you can play along until you replace C. Actually, like Zig, you could use it as a cross compiler, like a cross-platform drop-in replacement for a C compiler. Like you could say Zig CC and then compile, you know, I thought Zig was a C++ hybrid. Not really. It's not really trying to become C++.
Just C.
Just C. In fact, even more than C, because there's some crazy features that we didn't get into in this video, but hopefully in the next videos, like packed structs and such, and reflection, which really makes serialization and advanced metaprogramming stuff very easy to do. Although the LSP is trash currently, but well. Though Rust is the one that tries to replace C++. Yeah.
Also Carbon.
I don't know about Carbon. Like, is it still up even? Fair, but I don't think anything will replace C for me, to be honest. I get why you would want to. Very annoying sometimes, but I enjoy. Yeah, I actually enjoy that too. But I think Zig is like, it's C, but more advanced. Like, in fact, I think Zig is way more level than C, to be honest with you. It's way near the assembly because you can do some crazy stuff with it when it comes to data handling. But well,
I've seen some crazy like thread stuff going on in Zig.
What do you mean? What did you say? Can you hear me?
I've seen some low level tricks performed.
Oh yeah, by the way,
that
there's also this std multi-array list. In fact, there is a lot. We have to actually cover them in the next ones. But today we've just gone through some basics and pretty much. But like there's this multi-array list, which is of course using Zig CompTime. And it basically makes data-oriented programming way easier. Like, it's just transparent and way easier. And by the way, the Zig standard library is the most readable standard library you could ever find. Because there's literally no hidden control flow, no operator overloading, none of that. Everything is very simple. Instead of having templates and so on, you know, just take types, take them as arguments, and there you go, done. IDK Go is pretty, I don't know, I didn't find, like, I haven't tried Go in detail, and if someone wants to teach me Go in some stream, let me guys know, you can DM me. But
that was very opinionated.
But I honestly currently don't see that much advantage in Go relative to Zig and Rust? Should you go if I could find a time? Yeah, it was nice and simple like Zig, but a bit higher level. Yeah, if someone wants to teach me Go at some point. Next weekend we have one person there scheduled. Emote super useful for RESTful stuff. Nicest lang I've used for it. Have you used Rust though? Have you used Rust and Zig? What about that?
Knows about Rust and Zig, honestly.
Because I'm seeing Go right now from the lens, the fact that I already have Rust and Zig basically. That's why I'm not seeing the point in Go. But like if I came from C and C++ and seen Go, I'd probably like it. Maybe.
I think basically Go is like Python, except it's compiled.
I've used Rust, didn't like it. Go is closer to C. Rust is more like C++. Didn't like. Go's close.
Rust does have a lot of features in a
Yeah, it's similar to C++,
not,
but bruh, it's just a power language. If you really take the time, it's a very steep learning curve, but if you take the time, it can give you really a lot in the kind of like higher level. But if you're gonna be dealing with a lot of buffers and low level nasty things, you really want something like Zig or C, not really Rust. Rust really sucks when it comes to unsafe code. That's why later on I want to actually use Zig for unsafe stuff and Rust for safe stuff.
what is wrong with Zig for high level stuff that makes Rust so good?
Asynchronous. So safe asynchronous multi-threaded code. Especially if you're working on servers or some safety critical systems. Oh my god. You really need Rust. And also iterators, functional programming in Rust. Oh my god, that's pretty good. Go's amazing for asynchronous. Yeah, I've heard good things about Go multi-threading and asynchronous. Yeah, kind of simple TypeScript like Python. When there's an issue, they solve it with more Go code, whereas solved it with a new lang feature more like. Yeah, that's true. That's true. Though Zig, as you've seen, even the syntax, like if you wanna declare struct instead of saying struct hello and a new syntax. I mean, just say const vector equal to struct. Just reuse syntax. Come on, it's that easy. Yeah. Anyways, go sell it. Sale pitch? Go, sale pitch. Over. Yeah, sure. Yeah, Zig not great in that space. Yeah, Andrew has ideas though. Zig though, I'm really looking forward for its release, so things will become more stable. Because right now it's kind of messed up. That's what he tells me, at least. He's had a good track record thus far. Oh, Jonathan Marler. I think I know you. Hold on a second. I think I know you. In the Zig space. Yeah, I know you. I see. So last time I've seen you, it was in the X11 library, right? X11, GitHub, Zig. Yeah, I've seen some interesting stuff, things you've made. Yeah, some pretty crazy stuff. So yeah, I recommend Chicken Name. Ouch, it's pretty good, pretty sick stuff actually. Love that when it comes to Zig. So yeah. All right, so
Nice, a Zig kind of guy.
yeah, pretty much is the Zig guy. So
I will say, I don't know why I'm banned from your chat. When I type in it, nothing appears for me.
weird. I have no clue.
But also, I have no clue either. But also, I saw that you like C# a lot. apparently.
Huh, where?
It's your fourth favorite language. It's on your Discord.
Ah, yes. Well,
It's your
C
fourth favorite
sharp
language.
is... I'll surely use it if I don't want to deal with memory anymore. That's my go-to. If I hate managing my memory, I'll go to C sharp. Sometimes I do get, how can I say, tired of managing my own memory, so I go to C sharp. A very similar top language list: Zig, C sharp, Python, C. Yeah, pretty much. Go, I think, doesn't have even generics, isn't it? And generic programming, I just love it. Although sometimes, it's more of a waste of time sometimes. Generic programming. Yeah, Go has generics now. Interesting, I see. But yeah, I really love generics, especially in Rust. Like, Rust have the trait system. So there's even this library right here, Rust. Oh crap. Hold on a second. There you go. You have this library right here, traits for algebra. So it's basically making a model for algebraic stuff on top of the Rust generic trait system. It's like all of the rules at compile time is just very wild. Like very high level algebra stuff. It's very crazy. It's not the most productive thing you could do, but like, man, I just love making stuff generic and go wild with it. Like in Rust, it's not like C++, like you have a template, you try to compile that, like what basically C++ does, it replaces that generics, well, not generic, that those templates into the code and see if it compiles. If it compiles good, you got an instantiation. Otherwise, it goes to the next possible instantiation. Try that. If it doesn't work, sorry, not instantiation, it's specialization, right? If it doesn't work, like if none of them works, then it would go ahead and basically to throw an error, the typical C++ template error that is longer than your screen, basically. Though it's becoming better with modern C++, with C++ concepts, which is basically kind of similar to Rust traits system. So basically in Rust, you cannot assume anything about generics. Every single property, like, you have to declare it beforehand. So like, is the T, like if you didn't declare that T can be added to another T, then you cannot add them in the implementation, in the generic implementation. But yeah, you can see my other Rust videos pretty much. This won't fix its problems with file systems and the fact that it assumes that every string is UTF-8. Also the error handling. Means a bit high level, mainly for web stuff. Web is mostly UTF-8. I prefer error returns, but that's just me. I like having complete control. The control flow, try catch makes some weird stuff. Yeah, I also hate try catch. It's always result value. It's always results.
Right catch.
Rust uses results, Zig uses results, and there you go. But yeah, that was a lot of fun, guys. Thank you for coming in. Thank you all for coming in. That was really a lot of fun. I look forward towards tomorrow, after tomorrow, and so on. I try to basically make a stream every day as much as I can. So yeah, looking forward for meeting Trey 2K in Sunday, and maybe tomorrow we're gonna have who? Maybe tomorrow we're gonna have who? Bruh, hold on, where is it? Yeah, Beirut, possibly. He didn't confirm to me yet, but we'll see. So yeah, that was it for this stream. And see you later, guys. Goodbye, everyone. Thank you for tuning in.
Go.
Bye.